Hello and welcome back to the Cosmic Acad. In this video, we will learn about RabbitMQ. It is one of the highest demanded skills employers are looking for nowadays. And it does not matter whether you are a backend engineer, developer, data engineer, or you aims to be an architect. RabbitMQ will help you achieve a scalability and it is of course fault tolerance. We'll discuss all those concepts along with this tutorial. By the end of this video, you will have solid understanding of RabbitMQ, which you can apply in your project or wherever you are working. And trust me, if you have these skills, you will be able to design a very highly scalable system, which every company needs. I request you to watch this video till end, even if you are a beginner or a professional. You would have a new concepts and understanding of RabbitMQ, and if any point of time you face any issues understanding it, please let me know in the comment section. I will address all those. Please keep subscribing my YouTube channel and support me. Now let's understand the problem statement and why we are going to use RabbitMQ. So let's imagine a pizza shop on a busy Friday night. So everyone start ordering the pizza, right? When it's a weekend. So the phone keeps ringing with the orders, customers are lining up at the counter, and then delivery drivers are anxiously waiting for pizzas. What will happen? So basically, chaos will begin, right? The cashier is overwhelmed trying to take orders, managing payments, and answer questions, right? The chef in the kitchen can't keep track of which pizzas to make first and which pizzas has been baked completely, and which pizza has to be delivered. And in that case, even delivery drivers don't know which orders to take ready there, right? So what's the result? Customer will get angry. They can miss the orders while delivering, and of course a stressed or team will be there. So whole team will get stressed. Now the shop has no proper system to handle and streamline this mess, right? So to resolve this similar kind of issues, RabbitMQ has been introduced. All right. And now let's imagine we introduced RabbitMQ to our pizza shop. Think of RabbitMQ as the middleman. Alright, so RabbitMQ will be acting as a middleman between the client. Client is nothing but the user who is going to order, people who is going to order for pizzas. Okay, so it will act as a middleman, and then that handles all the communication between the cashier, kitchen, and delivery drivers, right? So if there has to be message delivered to a specific person, whether that is chef, whether that is staff, waiter, or delivery person, that message has to be delivered to the specific person, right? And RabbitMQ is going to play that role. It will pick up message from somewhere and deliver where it has to be delivered, right? So here I just created this architecture flow and I will explain how we are going to proceed. So very first, customer will put some order and then order will come on pizza shop, right? So you can think this WebSocket server as a pizza shop. Order will come here and then RabbitMQ will pick up this order. All right. Once this order has been picked up, RabbitMQ will manage a queue of all those orders. And what is that queue? That queue is a message queue. Now in real scenario, you can assume this message queue as a to-do list where you are going to put all those items which has to be completed. So RabbitMQ will do the same thing. It will take out all those orders, pick up all those orders, and then it is going to make a list of all those orders, and that is nothing but the message queue. All right. Then based on this message queue, the message will get delivered to the kitchen. So RabbitMQ will say, okay, I created this to-do list and then this order should be delivered to the kitchen as well so that they can start preparing those orders, right? So in this case, kitchen will be consumer of the order. You can assume this consumer as a kitchen. So kitchen will pick up all those orders one by one and then start processing those orders. And how kitchen is going to process that order? Of course, we know kitchen will have multiple staff, chef you can say, right? So chef is going to prepare that pizza, and then in this case, in terms of technical terms, we'll be using Golang, and of course for preparation or order processing we'll be using Go routines. We'll talk that in details, but let's first understand how we are going to make it. So here chef will act as a, it will just take that order and start preparing those order. It will do processing on order, right? And then once the delivery is once the pizza has been baked, RabbitMQ will do what it will do is it will just go here and pick up those message. Okay, this specific order has been prepared, and then the same message will get delivered to delivery boy, you can say, right? So once that message has been delivered to delivery boy, where that pizza has to go? It has to go back to the client or back to the user, right? Or back to the people who has ordered those pizzas. If you have ordered those pizzas, you will get that pizza back, right? Or at a regular interval of time, you will be getting the message as well. For example, let's say you placed an order, RabbitMQ will pick up your order, and then RabbitMQ will create a to-do list in that your order is there. Okay, order number 1, right? And then kitchen will pick up your order from the queue and then hand it over to the chef. And in this case, chef is going to be Go routine. Since we are going to use Go routines with RabbitMQ in this tutorial. So now chef will start preparing those orders, and at regular interval of time, we should also convey this message. We should also send some notification to the client that your order is being prepared, right? Your order is in midway. Hold for some more time so that your order will get delivered, right? And how we are going to send those messages? We are going to send, again, RabbitMQ will pick up those messages from the chef and deliver it to delivery boy. All right, and then of course the message has to pass to client as well, which is of course in this case user, you, who has ordered this pizza. So how we are going to send this notification? So for sending notification in this tutorial, we are going to use a simple WebSocket connection, and there will be only a single client or single user who will be doing all these operations. But throughout the course, we'll be following solid principles, we will be following modularity, and we will be doing it in a very efficient way. All right, and we will learn a lot of concepts like handling Go routines and RabbitMQ channel, publish, consumer, and everything we will learn in this tutorial, right? So without talking much, let's get back into code and we will start making our application. So for that, where I need to go, I will create one folder over here and you can follow me along. So I'll say, let's say pizza shop. So I'll say pizza shop, right? And the folder name I'm going to create with hyphen. You can create with any name you want, but in this case I'm just going to demonstrate the example of pizza shop. So I am taking pizza shop here, and I will be just opening this in a VS Code. So let me just open this with VS Code, and I will maximize it. And so what we will be doing here is we'll be creating a Golang server which will have a feature of WebSocket connection as well, and then we'll be having a RabbitMQ connection as well. So basically we'll integrate RabbitMQ and WebSocket with our Golang server so that we can, we can streamline this pizza order process. All right, and then we'll be creating client as well, so that we should be able to we should be able to order pizzas from our client, from our UI, right? So without talking much, let me just create one folder over here, and this time I'm going to say it as a server, right? And very first thing what I'm going to do here is I will just open a terminal so that we'll have access to the command, and using command we can initiate a Golang project. And if you guys are beginner, you don't know about how can we create Golang project and what is Golang, you can go to my previous playlist and check out those videos. So without talking much, let's create this, and I will say go mode init, and this time I'm going to say github.com, and then I'm going to put my name here, Mohammad Zaid Hussain, and I will say pizza shop. Alright, pizza shop, and finally I will just put enter, so that Golang will create a mode file. You can see here where all those dependency has to be managed, but you can see here this file is actually created outside of the server. My intention is to create this project inside a server, because this Golang is of course going to be a server application. So I'll just do one thing over here. I will just move this file into the server folder, and then we are good, right? So this time I'm going to go inside a server folder, so I'll say cd change directory to server, and now we are inside server folder, right? So couple of dependencies which we need to download, and I will paste all those dependencies in the description, so you can use that command and you can download all those dependencies. Apart from that, I will also post this link to the description so that you can get this code from the GitHub directly. So here I'll say go get, and I need very first thing is a .env configuration, and for that I'm going to use a package of Golang which is Zoho, and then go.env. Let me just download these dependencies, and then we'll download a couple of more dependencies so that we will be using all those dependencies in our project, and then our application should be working in an expected way. So for making it faster, I will just create one more terminal from here, and then I will say okay, this time go get and github.com, and I'm going to use RabbitMQ here, and for that we have a standard package RabbitMQ /amqp 091-go. Alright, so let's install this as well, and we can see here there's some issues. We cannot do this outside of this server folder because our dependency file module file is there inside this server. So we need to go inside server folder and then execute this command to download the dependencies. And here we can see this go.env is downloaded, and then I will use Gin throughout this video for routing and creating our application. So I'll say go get, and then in this case as well I'm going to use github.com. These all are packages which are present on their website, right? So I'll say go github.com, and then I will be using Gingonic, whatever you want to say, Gingonic or Gingonic, whatever. So I'm going to say it Gingonic. I'll say okay, just download this, get me this package as well. So I'll say enter, and then we can see here we have this RabbitMQ package download as well, and then I need a couple of more packages to create a WebSocket connection. I'm going to use Gorilla package, which is very popular, and you can use whatever you want, any package which you are comfortable with, and make sure that package is of course following some standards. There should not be a lot of bugs, right? So here in this case I'm going to say okay, go get github.com, and then that package is Gorilla WebSocket. So I'll say Gorilla WebSocket, enter. Let's see if we'll have all those packages ready here, and then if this is happening, I will just create one more terminal over here so that I should be able to download more dependencies parallelly, and it should not be taking a lot of time. Okay, we can see here it's downloaded, so I will use the same here. And this time, do we need anything? I think no, we don't need anything. We have WebSocket, we have .env, we have of course this RabbitMQ, and that's what we discussed over here, right? We are going to create a server using gin, and then we are going to create a socket connection as well, and for that we are going to use Gorilla WebSocket, and finally we'll be having a RabbitMQ. This consumer and everything is going to be nothing but a concept, so that we can make it a real example. We can make it, working example, so that we can implement using Golang itself. So we will see how we can implement those things. So let me go back in code, and I will first go inside this server folder and say, let's create very first thing over here, and I will say config folder. So once more, if you want to follow different folder structure, of course you are free to follow that, but here for just simplicity, I'm going to say okay, config, and inside config we'll have .env related configuration. So for that I'm going to say okay, create one file over here, and this is going to be env configuration, so that we can manage all those env, all those URL right onto the env property, and then using env property we should be able to use that in our program. So I'll say .env, it should be env and config. I'll say once again, if you want to name it as per you want, you can name it, no issue, and then I'll say .go. So I will be creating a couple of methods here which we'll be using throughout this program, and then it will be working in expected way. So very first thing I'll say okay, env, and then I'll say config.dtu, right? And then we are going to define config.dtu as a struct here. So I'll say config.dtu, and it is going to be of type struct. So I'm just going to write this code faster, and if you want you can watch it as many as time you want. If you're a beginner, of course you will be struggling to understand this, not struggling, but you will have some kind of difficulty understanding this. If you don't know about Golang, please go back to my playlist and check out those Golang videos. I have basically published those videos with very detailed concepts. So here very first thing I'm going to say port, it will have a port, and I'm going to use a string, and then I will have let's say RabbitMQ. I will have RabbitMQ, and this time it is going to be host. Of course, host is nothing where your RabbitMQ is running, that is going to be URL, right? So RabbitMQ host will be there, and a couple of more variables related to RabbitMQ. So I'll just copy this and paste it here, and in this case I'm going to say host will be there, of course. Then we'll be having username as well, because to authenticate, to connect with the RabbitMQ, we'll need username and password as well. So for that we'll have username and password, and then of course port should also be there so that we can connect to RabbitMQ on a specific port. And here I'm just going to say RabbitMQ default, and I will say Q. And why is that so? Because let's say when you are starting your application at the very beginning, there won't be any queue present inside your RabbitMQ. If you want, you can go inside RabbitMQ UI console, and then from there you can create. Of course, that is one way. But then if your application starts, I want this default queue to be there. All right. So we are good with this, and then I will just create one function, I will say func, and I will say config env. Env is nothing but short form of environment, right? So I will say okay, that's fine. So you just do one thing, env, just initialize this env basically. So I'll say okay, config.dtu, and we should have all those property here as well. So what I'll do here is I'll just copy this from here and paste it here, And in this case, what I will do, let's first align it properly so that code is more readable and it looks good actually. So instead of a string here, I will say, okay, let's use OS package. And OS package, okay, very first thing you need to define a package over here, and this time it is going to be config, because this file exists in a config folder, config package. So now here I will say port is going to be OS, and OS is one package inside Golang. I will say OS dot get env. All right, not there, it should be here, get env, right? And then here I will say, okay, this port, capital PORT, anything which you want you can name it, but then it will be available on .env file, and then it will pick up this port and map this port into this specific port. Cool. So next what I'm going to say is, okay, that we did for port, because our application, our main application, pizza shop application, will be running on a port, right? But then we need some more thing over here, and for that I will just copy this and paste. So I will say, okay, that's fine, let's Control D and paste it. Finally we'll be just changing this. Okay, we have OS over there, we'll do that. So this time I'm going to say RabbitMQ host. So RabbitMQ, and I will say host, and I will just copy this and paste it everywhere in this get env. It will be actually easier to write, right? So I'll do Control D and paste it, but in this case it should not be here, it should be port, small port, the same which we have defined over here in the struct. All right, so RabbitMQ host is there, that is completely fine, but then in this case it should be RabbitMQ username, right? And in this case it is going to be RabbitMQ and password. All right, and here it should be RabbitMQ port, not the host, of course. And then here also we need to have a different variable, so I'll say RabbitMQ default, not like that, default and q. Let me just save it, and this OS will get imported over here as soon as you will just save this file. So okay, we have this method ready, and then we'll be creating a couple of more methods. Okay, very first thing I will say init. What is init? I will just give you a simple definition of it. So whenever any Golang file runs, it will first invoke this init function. Even if there is a main function as well, this init function will get executed before the main function. And this was designed just to initialize all those variables which you are defining in your application, so that code will be more modular, right? So I'll say, okay, this time I will say env dot port. If port is not there, right, in that case just config this env, just call this function, and we know how can we call this function simply, right? So by default, if our application will start, right, there won't be any configuration and port will be empty. So it will just call this config env, so that we'll have all those variables which we are defining over here. So let's go ahead. We should not spend much time here on configuration and all. We should be seeing that RabbitMQ, we should be talking more on RabbitMQ. But before that, I just want to make sure we have all those utilities function, so that we can make the pizza application work. So here I'll say just access field, there's one more property over here, not property but the function will be just passing this key. You can see here that in struct we have defined this key, right? So we'll be passing the same key over here, and we should be getting those values. So in this case I'm going to say, okay, key and is going to be type string, and now this will give you two different things. First is string and then error. All right, so very first thing I will do value, and I will use the reflect package this time. And if you're not about the reflect package, please watch the videos, read blogs on reflect. So I'll say reflect dot value of, there's one method value of, and then here we will be passing this env. All right, And we have type as well, so we will check the type. So v dot type, so what is going to be the type of this, not like this, we'll say v dot type. So what can be the type of this specific env, right? And of course this time type is going to be struct. So I'll say if t dot kind, right, kind not equals to reflect dot struct. If the type is not struct, then of course there's something wrong happening over here, because we have defined type as a struct. So I'll say empty, and then if you want to skip this videos, you can skip this until a specific duration, and then from there you can play with when we are going to integrate RabbitMQ and all. But this is very important you to learn to make your application highly flexible, highly modular. Alright, so this will help you throughout your developing journey. So I will say okay, fmt dot error of, right, and this time I'm going to say expected struct, okay. Now without logging much, I will say okay, that's fine. Now let's do one more thing over here, and this time I'm going to say okay, t dot field by name. Use this method and it will give you a struct field, right? And how can we do that? We'll just pass this key, and then we'll check for error as well. Not error, but we can say okay, if that is there or not. If it is not there, we'll again say okay, return empty string and then error. So this time error will be field not found, alright. So if you want to log it more in a structured way, you can of course use a printf function or printf function, so that you should be able to debug this very easily. Now here what I'm going to do is I'm going to finally take out the value, and I will say v dot field by name, and then I will just pass this key, and I will return f dot, and then I will just use a string value of the specific item, because whatever value which is coming from env property will be as a string. So, and of course here we are returning a string as well, so we'll say okay, and this time error won't be there, right? So we have this function ready, and then finally I will create one more function over here. I will say load env environment variable, or we can say load env variable, and then in this case I will do a couple of things over here. I will just check for if there's any error. What kind of error will be there? Why we are making this function? So we'll understand it. Let's just see this, and I will say okay, error, and this time I'm going to use os dot stat. Okay, what it will do is it will just give you the file info. Okay, and I'm just checking for this file env. Alright, basically we are checking for the env file. If that file exists, and error is going to be nil, right? Then only we are going to initialize this config. Then only we are going to use this .env, go.env, which we have downloaded in the beginning of this video, right? To load all those env variables from the env file, and then it will map it into your application, right? So I'll say okay, error, just use this error once more, and this time I will say go.env, which we have downloaded as a package, and I will say load. This load will actually map all those variables to your application, right? Cool. And I'm just going to check for error. If error not equals to nil, right, and if it is not nil, we'll just say fatal, because there's no env and your application should not be working in an expected way. So it's better to instead of fatal, we can say okay, just panic, because you should not run this application anymore now. So I will say okay, error loading env, fine. Now we are done with this, and here we should have else condition, and here we will say okay, if env is not there, then just use the system variable itself. So in that case I will be using, okay, before that I will just create one more folder over here so that we can centralize all the logging process there. And how can we do that? So I'll just say logger, and inside this logger I will create one more file over here, and I will say logger.go. So everywhere in the program, in this tutorial, basically we are going to use this logger. And why we are going to do this? Because we can centralize all those logging functionalities, right? And why we are centralizing, answer is because this centralized should be working based on configuration. If we will pass those configuration from the env, then only I should be getting log, or else I should not be getting logs. That is the proper way of implementing log functionalities. So I'll simply say package logger, and I will use a simple method over here. If you want to modify it, of course you can modify that and make it more efficient and make it more flexible as well. So but for the time being I'm just going to centralize it. I'm more focused on centralizing this, and I will say is logged in, not logged in, is enabled. I will say is log enabled. All right, and then I will say os dot get env. We have one more method over there, and I will say just fetch for this property in the env file or in your system. So if it is there means we'll just check for if log is enabled, or we can say if log enabled not equals to empty, that means log is there, then just do log. And for that I'm going to use log package from Golang, and I will say println, and then I will just pass this message over here. We are good with this logger, and then we'll be using this logger here as well. So how can we do that? We need to import logger package over there, right? So just import that logger package here, and it is of course automatically imported when you will click on that, and we can use this log function now. And in this case I will say no.env file found, it's using system env configuration, right? We can say conf. So let me just save this. We have this function ready as well, and then finally we'll create one more function, final function, and I will say get env property, which will get exposed, and we'll be using this function throughout our application. And I will say okay, property key, and then I'll say string, and this will give you just string value because this is going to return you the configuration properties. And in this case also I will say okay, if env.port is not there, that means your variable has not been loaded. So in that case I will say okay, config your variable. So for that we created function config env, right? And then we'll say okay, value and error as well, but in this case we'll be calling access field because we have created access field so that we can fetch the value based on the specific struct name key, right? So I'll just pass this key, property key, over here, and we have value and error as well over there. So here we cannot do like this. We need to say okay, if it is empty, right? And then if we have value over here, we'll just check for error. Okay, just return this value, since value has to be returned, whether it is empty or anything, but it has to be returned. So I'll say just if error not equals to nil, and in that case I'm going to say logger.log, and then I will say fmt.printf, and in this case I'm going to say error accessing field. That means there's no field at all, field. And what is the name of the field, that you can log here as well. So I'll say property key. All right, so we are good with this, and what we will be doing next here is we will load this env variable somewhere here. And where we are going to load that? We are going to load that in config env as well. so that we can make sure it is loaded properly. And if it is repetitive task, of course we can eliminate from here, but for the time being I'm just leaving it here. Let me just save this, and what I will do here is I will go back here, and this time we are going to use RabbitMQ finally. So what I will do here is I will just create a configuration so that we can we can have a certain functionality on this RabbitMQ, and using that functionality we should be able to construct those pizza shop, and we will see how we are going to do that. So here I will say RabbitMQ, and if you want to follow different way, of course you are free to follow, but the concept will always remain same, right? So I will say RabbitMQ, and then I will say config. File name should be very descriptive, and it should basically perform the specific action as well. So we are good here, and first thing first I will say RabbitMQ, and then package we should define. So I'll say config, and then we should be creating couple of function which we are going to use throughout this application. Very first thing I will say create a RabbitMQ connection. So I'll say RabbitMQ connection, and this time it is going to be a struct. So basically this will hold the RabbitMQ connection. So, and what is the connection? You can think connection, you can think connection of like you are going to connect with the RabbitMQ through call or through something, and then RabbitMQ is available for you, and you are storing that connection somewhere, right? So similar thing we are going to do here. We are going to use RabbitMQ connection. We are going to store this RabbitMQ connection here in the RabbitMQ connection. So I will say, okay, that's fine. Get me a pointer of this. We need address of this instead of, this value. And if you don't know what is called by value and called by reference or pointer, do watch my previous videos on pointers, called by value and called by reference. You will be able to get it very easily, easiest way ever. So I'll just say, okay, use this package since we have downloaded this package at the beginning, and then I will say I need connection this time. So I'll say connection, right? Now I need one more thing over here, queue. So we know that if I'll go back here in our application structure architecture, so we know that RabbitMQ is going to maintain a queue, message queue. It is nothing but a to-do list for RabbitMQ, right? So where this queue will be. So we are going to store this queue in a RabbitMQ connection, right? So let me go back here, and I will say this queue will have some name, right? Of course, name will be there. Now, next thing what I'm going to do is I'm going to create a function which will initialize this connection. So I'll say get new RabbitMQ connection. All right, and then it will be returning, of course, this RabbitMQ connection, right? So very first thing what I'll say here is host, and then from where this host will be coming. We know that we have created those env. That's why I was more focused on creating this kind of utility function so that it will be very easy for us to maintain all those configuration. So we have defined all those RabbitMQ related configuration here, and we will be using the same. So I will just go here and I will say, okay, host will be coming from env. So for that we have get env property method which we have created in env config, and here we know the key. So we will say, okay, it will be stored as a key RabbitMQ and host, right? So I'll just copy paste this, and this time it is going to be port, and then we can say username will be there, of course, and then password will also be there. Finally we'll have a default queue name as well, right? Now we need to change this key as well because we have defined this key in the struct over there, and we have different key. So for port we have RabbitMQ port, and for username we have RabbitMQ username. So we will say username, and for password we have password, right? And then for queue, default queue, I'll say default and then queue. Fine, we have all these property now in our hand. Now using this property, RabbitMQ says, okay, if you want to connect with me, if you want a connection with me, you should have all this property. Using this property only, you are going to connect with me, right? Like if you are going to call someone, you should have a mobile phone, you should have a SIM card, and you should have an active connection in that SIM card. Then only you are going to align all those mobile phone SIMs, and then finally you will be able to call someone, right? Similar thing here, we are going to call this RabbitMQ, and once we'll call, we should be storing that connection. We should be able to save that connection somewhere, and of course in this case we are going to store that on RabbitMQ. So here what I will say is, okay, port and then error, all right, and I will use, since this port we are taking it here, this port should be actually not in the string format, it should be in an integer format, right? Because port will be an integer, a number. So for that, what I'm going to say is, okay, let's create a variable port and then use a string conversion library, and we have method over there as a to I. So it will convert the string to you can say to number, and basically it will convert only if that is a number. So here I will say, okay, this port will be a number for sure, but it is wrapped in a string, double quotes, right? So we are good here, but then we need to check for error as well. So I will say if error not equals to nil. We don't have concept of try catch everywhere in Golang. We don't have concept of try catch itself. So we need to process this error manually, and or else we can centralize this error handling mechanism as well. We'll see that in action. So for now, just use this, and if you want, you can of course optimize this and make it work in expected way, right? Just for simplicity, I am using it directly so that I can connect with you in a very easy way. So I'll say, okay, that's fine. If that port is not there, of course the call is not going to be connected to RabbitMQ. So I'll say, okay, then use this panic. That means your application is not going to run. Now next what we are going to do is we are going to just put some message over here. I will say use sprintf so that we can log a specific message or in a certain structured way. So I'll say, okay, that's fine, just use this message invalid port, because this port is not a string, or this port is empty string. So I'll say, okay, I'm going to log this value here, and in that case of course error should be there. And what if we have port? Then if we have port, we need to properly dial up a connection to connect to the MongoDB, and for that we need a combination of all these things, like we talked about in case of if you are going to call someone, right? You have to have mobile phone, you have to have SIM card, and then active connection as well. So aligning all those at single place, you should be able to dial the number, right? So similar thing we are going to do here. I will say, okay, dial this number. And how can we dial? So before dialing a number, we should have that number in a specific format, right? So for that, I'm going to use a sprintf to structure that number in a specific format, and this time I'm going to use AMQP. AMQP is nothing but a protocol to connect with the RabbitMQ. It is a set of rules basically. So I will say this protocol says basically your URL should be in this specific format. So I'll say, okay, that's fine. Then there should have a string here, and I will say what string should be injected there, what string should get replaced here. So I'll say, okay, that's fine, and then I should have @ and then again percentages, and then again colon, and this time it is going to be port, right? And finally I will say, okay, that's fine, and there should be slash as well. Now let me give all those variable over here. So very first percentages which you saw here, it should be a username, and then followed by password and host, and finally we should have a port. So we have all those details here, and these all details will get replaced over here, get injected over here in place of this percentages. Percentages is nothing but the formatted format of string, right? Now we have this number ready to connect to dial to the RabbitMQ. I'm sorry, I'm saying MongoDB more than once. So we are good with this. Now finally, let's dial this. Okay, so how can we dial this? So we have AMQP dot dial function, right? And it accepts a URL which we have created over here. So we'll pass the URL over here, and then we should have a connection, but before that we need to check for the error as well. And in this case we'll check again. What I'll do is I'll just copy this error from here and paste it here, so that we don't have to write this code more than once. And here what I will say is, okay, failed to connect to RabbitMQ. Maybe RabbitMQ is busy or RabbitMQ is not available, right? And what if if RabbitMQ is not available? Of course, this system won't be working, because we'll be having a lot of order, but then who is going to streamline those orders? Who is going to align all those messages, right? Again, we'll fall into same problem. So we are expecting RabbitMQ to be there, and if it is not there, we are not going to operate the shop, right? Because operating shop won't be efficient. All right, again things will get messy and everyone will get tensed. So for that, what I'm going to say is, okay, that's cool, you just need to panic. Fail to connect to MongoDB, not Mongo. Again, I'm saying MongoDB, I'm sorry for that. And then RabbitMQ should be there. So here I will say, okay, RabbitMQ, finally we should print something, we should say something to the console, right? So I'll say log dot, this time I'm not going to use logger, because anyhow this should be printed whether you are configured or not, because that is only way we can see this console when our application is going to run. So I'll say logger.log, not log, it should be logger actually, logger dot, and log, not we are not going to use that. So I'll say logger dot, okay, log.println. I'm sorry, I forgot that method name. So here it should be, I will say RabbitMQ has been started or connected. So I'll say connected, and once RabbitMQ is connected, we can save that number here, and not number but the connection itself. All right, and how can we save that? So we'll say this time this function is returning this RabbitMQ connection itself, right? And it will have a connection as well as queue. So in queue means you are handing this queue to connection RabbitMQ, saying that this is your to-do list. Okay, so I will just say, okay, return this RabbitMQ connection, but then this RabbitMQ connection needs connection. So I'll say, okay, you need connection, I will give you connection, and we have those connection over here. So I'll use the same connection to assign here. We are good, and we need queue name as well. So we have queue as well, so we'll say queue. You can see here we have imported default queue, right? So till here we are good, right? We don't have any issue. We have a function to get connected to the RabbitMQ, to call RabbitMQ, right? Now next function, one more thing I want over here. So whenever, let's say there's some error occurs or there's something happened, because of that connection got cut, right? So I want to explicitly say this to RabbitMQ or to this function, okay, just dial once more. Okay, dial once more, so that we'll have a new connection once more, and this time we don't need this RabbitMQ connection, we need only connection. So what I will do here is I will just copy this from here, because we need similar functionality here, but we don't need this RabbitMQ connection. Or else we can say, okay, that's fine, just register this function on this RabbitMQ connection, so that using this, wherever we are using this get new RabbitMQ connection, we should be able to call a connect method. And how can we do that? So we know that how we are going to register method on a struct, and this is of course RabbitMQ connection. So I'll say RabbitMQ connection, and we are going to name the method. So this time I'll say connect. Okay, and this connect will actually return RabbitMQ connection object.
So I'll use this MQP and then it have this connection struct, right? So now this connection struct will get returned, and of course on connection struct there will be a lot of functionality or property will be there. So we'll be using those all functionality or whatever is there. So we'll deep dive into that slowly. So here what I'm going to say is, okay, we have connect method over here, but then the functionality should be same, right? So what I'm going to say here is, okay, if functionality is going to same, so I'll say, okay, connection, or I can say RabbitMQ connection, RMC, and then I will say just call this get RabbitMQ connection. So I'll say get RabbitMQ connection, that's cool, but in this case, this RabbitMQ connection instance will get returned. I don't need this actually. So for the time being, let me just copy this from here and pass it here. Not here, but I'll just copy paste this here to make it simpler. We don't have to mug up this with RabbitMQ connection because this connection has to be one only, not more than one. So that's why I'm using this separately here. And then in this case, we don't need queue and all, so we don't need that. And of course, we have connection over there. We just want to return connection. Connection, fine, we are good with this. And then here, we are going to say RabbitMQ has been restarted, or we can say reconnected, because this method we are going to call explicitly if there's any error, and because of that, connection got cut, right? There's a storm in your area, and because of heavy storm, heavy rain, you are not able to call RabbitMQ. In that case, you should be saying, okay, just try connecting if it is possible. So let me just save this. We are good with this function connect, and then we should have a couple of more functions related to RabbitMQ, and I will tell you exactly why is that so. So now this function should also be on RabbitMQ connection. So I'm going to name it declare queue, right? Even though we are going to use a default queue over here, you can see we are storing this queue over there, but then if we will call this declare queue, means we should be able to create, it should be able to create a new queue. That means it should be able to create a new to-do list for himself, so that he can use those specific to-do lists. Let's say RabbitMQ is going to handle a lot of tasks, lot of different tasks, and then the task cannot be, he cannot put the task on the same to-do list, right? For each of the item, you should have different to-do list, right? For example, for a study, you should have a different to-do list. For playing, you should have a different to-do list. So similar thing which we are going to do here is it will just create a to-do list for RabbitMQ. So I'll say, okay, declare queue, and then you should name that queue as well. So it is going to be of type string, of course, and then error. So now very first thing, I'm just going to define error. All right. And what I'll be doing here is I will just I will try to get a channel. Now just assume this, you're calling someone, you're calling this call to RabbitMQ. You are connected, right? Then if you are connected, how you are going to talk? There should be some communication. So if you're calling someone through your mobile phone, there should be a connection. You are using SIM card for a connection, right? There is a ISP or whatever internally they are using, but at last they are using something to, you are speaking something here, and at other end they are going to listen, right? So similar thing here, we are connected, but then there should be a passage, there should be a way through which we should be able to communicate our communication or our voice, right? So for that, we have a channel to communicate with the RabbitMQ. And same thing, I'm just going to access this channel. And how can we have access of this channel? I will say, okay, we know that this RabbitMQ connection here has connection object over there. So using that connection object, we can get the channel, and it will always give you a new channel. So I will say, okay, connection dot channel, and channel is a function, fine. but then it will give you error as well. So use error as well here, and then I will say, okay, if you got the connection, don't forget to close this connection as well. Let's say you are calling someone at certain point of time, after 20 minutes, 5 minutes, or after 1 hour, the call is going to be cut, right? You are cutting that call, or from either side they are going to cut the call, right? So for that we are going to say, okay, once the talk has been completed, all right, once we are communicated, we have conveyed all those things which we want to say, once that is completed, close this channel. We don't want the mobile phone to be connected every time to you, right? Whenever we need that, we will call, we'll get on a call, we'll connect, we'll use a channel to communicate, and then we'll close this channel. Similar thing we are going to do here. Not channel, this time we need to use this channel which we have created. Defer channel dot, and then channel have close method as well. So we can use this close method to close the communication. Fine. Now what I'll do here is I will say, okay, just use this, and this time I'll say channel. I will use this channel to declare a queue. All right. So it will just create a queue if the queue does not exist. So for that we have method over there, queue declare, and then here what I'm going to give is queue name. Very first parameter is going to be queue name, and of course in this case it is queue, right? Is it queue? Yes, it is queue. And then let's be more specific. I'll say queue name, and this should be like this. So I'll say queue name. Cool. And then what else parameter we need to provide? Durable. Yeah, we need this to be durable, and that is where fault tolerance come into picture. So at the very beginning, during introduction, I said RabbitMQ is a fault tolerance, right? What does that mean? So for that, let's go back to this architecture and just assume one more issue over here, and not assume, but see, we have one more issue over here. What if there's one order which someone ordered, of course, and this order is getting picked up by RabbitMQ, and then this order is, this order is in to-do list for now. It is not sent to consumer, it is not sent to order, it is not sent to kitchen to process or to bake pizza, right? It is still in RabbitMQ queue, RabbitMQ to-do list, right? It has not been consumed. And then RabbitMQ connection has been de-established. That means connection has been cut somehow because of any reason, but then connection is closed. Then this consumer, this kitchen won't be having more order. Let's say kitchen processed all those orders. This chef, whoever present there, have baked all those pizzas, but then there's no more pizzas left because there's no more queue present over there. There's no connection with the RabbitMQ. And we know that RabbitMQ has only this queue. So then how order is going to be processed, right? That is a big issue. And since this is application, RabbitMQ is again one application. So once it will die, it will crash, or it will close the connection, and if we will restart the RabbitMQ, or we will try re-establishing the connection, all those order will get lost because RabbitMQ is managing all those to-do lists in memory. It is not persisting those data somewhere on the hard disk or somewhere, right? That is a problem. So because of n number of reasons, the channel may closed, connection may get closed, right? Then how can we solve that problem? So for that, RabbitMQ says, okay, you need to tell me explicitly when you declare queue. You need to tell me whether this queue I need to protect it somewhere, I need to keep it somewhere, so that even if I won't be there, this queue will be there. This queue, all those items which we have listed on those queues, all those orders, it will be there. And whenever I'll come back, I should be able to see that order over there. And then again, this kitchen will start taking those orders. Right? So this is the concept of fault tolerance, and then this way our application is going to be highly available and highly flexible, highly scalable, right? Because even if system crashes, we don't care about anything. Order will be there as it is, and then the kitchen should be able to pick up all those orders, right? So for that we are going to say, okay, just persist this queue, persist this to-do list messages. All right. So now next, what is there? Auto delete. No, I don't want it to be auto deleted. All right. And what else? We have exclusive, we have no wait. So I'm just making it false for now. So if you want to read it more, you can read all those documentation mentioned over here. You just hover on that and you should be able to read all those things, right? So here I will say false, and then again I will say false, and then finally arguments. I don't want to pass any arguments. You save whatever you want. So I'll say nil. I think we have passed one more parameter. So now we can see here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, we are good with that. Now finally we have declared a queue, we have created a queue, and that queue should be persistable. That means it should, even if some connection got closed or there's no connection left with the RabbitMQ, still the RabbitMQ will have access to all of those orders, all of those items which has been mentioned on a queue, right? So now I'm going to say, okay, that's fine, let's return the error if there's any issue. All right, now we are good with all of this, and then finally a couple of more function will create, and this is going to be a helper function for us. So I'll say, okay, register this function on RabbitMQ connection, and this time I'm going to use, not use, but say get connection. All right, and it will return the connection AMQP 091 dot connection. And here I will say, okay, if r dot connection, that means already the connection which we made, if it is not there, then that means previous connection has been closed, right? So for that we are checking here if connection is nil over there. So we need to say, okay, connection is nil, fine, you need to reconnect, and for that only we created this function, right? Now you got it, right? Why we created this kind of function, so that we can reuse it in our application and make our application more robust. Great. And then once that is done, I will say, okay, you will have the connection now again, and then just return this connection. Cool. Now I will create one more function over here, and this time I need a channel. So I'll say, okay, we have connection, we need a communication passage through which we should be able to convey to others, and we should be able to listen back. So I'll say, okay, on this RabbitMQ connection, I will give you one more method, get channel. All right, and this will of course return AMQP dot channel. All right, and here we are going to do, okay, we are going to create one channel. Every time we will be creating a new channel whenever this get channel will get called, not the existing channel. Okay, why? Because we are going to close the existing channel which exists before, right? As already I said, when you are going to call someone, you are not going to use the same call, right? At certain point of time you are going to cut the call, and then if needed later point of time you can recall them, correct? So similar thing we are doing here, and in this case I am going to say, let's make a channel, not channel but pointer to channel, and then I will say connection. Let's create a connection object over here, and I will say connection. So if connection is there, of course we are going to use the same connection which exists, and if it is not there, we are going to create a new connection, and for that I will be checking, okay, if connection equals to nil, that means there's no connection exist, and in that scenario I'm going to say connection equals to r dot connect, right? We are done with this. Now I will say, okay, if that is fine, so I will have a channel as well, and this time I'm going to create a channel. So for that I'm going to say, okay, get me a channel. And how can we do that? So I will say use this connection, because we know that connection will be there now, and we need to check for error as well. So if there's any error, so I'll say if there's any error not equals to nil, in that case I'm going to say, okay, initialize this channel once more, get this channel once more. And for that I will say, okay, r.connection.channel. Okay, get this channel once more, try it once more. And then here I'm going to put log as well. So I'll say logger.log, so that we should be able to see what is happening over there. And this time I can say channel is nil, right? Channel was nil, that's why we created this channel once more. And I will put one more condition over here just to make this functionality, this functionality very robust, so that it should be able to handle all those error scenario. So I'll say if channel not equals to nil, if channel won't be nil, if channel is not nil, of course channel will be there. And then I will check one more thing, channel is closed, and I will check not closed, I will check channel is there, but then channel is closed, right? So there can be, just think of this, there can be a scenario in your area, let's say in your area when you're talking with your friends, there's heavy storm going on, all right, heavy storm and thunderstorm you can say, and raining, it's raining heavily. So you are talking with your friends, but then there can be issue with your channel, right? There can be a single way communication, you are saying something but your friend is not able to get that, right? Or your friend is saying something, you are not able to get that, right? There the channel is closed, even though you are on call, but whatever you are saying is not getting delivered there. That means channel is closed somehow, all right? So to avoid the scenario, if channel is closed, let's create new channel. So I'll say channel, and then again I will say error, and I will say r.connection, get me a new channel then. So I'll say connection.channel, right? And again we'll just check for the message. I will just copy paste it here if that is the case, right? So here I will simply say, okay, that's fine, we are no more going to create a channel now, and we are just going to check for the error. And log should be something like channel was closed, let's say channel was closed, and error creating channel. So that means channel was there, you were talking with your friends, it was there, but then it was closed because of some reason, right? So I'll say, okay, error creating channel, we are not able to create channel, fine. And finally I will be returning, we have handled all those scenarios, and then I will say just return this channel which you have created. Cool. So we have checked this channel, what is the error exactly? So channel and then comma error, we are good with this. Okay, we should not use this since channel is already defined on the top, so I'll just remove this. Not on the top, but here we already have defined that variable, so we can just use equals to, we don't need to redeclare it. That's the concept of Golang. So we are good with this get channel, and then one last method I need. If you want to create more and more method, of course you can create, and then it should be working as per your expectation. So in this case I'm just going to create one last method, and what is going to be the method? Okay, I'll say get queue. So I will say, okay, get queue, and then I can return this queue so that we can know which queue it is currently referring to, or which we can say basically this RabbitMQ is currently using this queue, right? So whenever we go in pizza shop, right, there we are seeing, okay, that a specific there we can see a lot of board over there, right, where the order is being shown. Okay, 201, your order is being prepared, right? We are seeing those board over there, we are seeing that kiosk machine over there, right? There we are they are showing the order. So similar thing here, RabbitMQ we are finding where this RabbitMQ is, mentioning all those orders. So for that we need this get queue method, and I will say return not return, okay, return r dot, and we need q, right? So we'll just say return r dot q. And of course, once we are done with the connection, we are done with this RabbitMQ, and we are just going to close the shop, right? We cannot open this pizza shop 24/7. Of course, you can open that if you want, but then there should be a certain point where everyone should go for rest, right? That is night 4. So here I will say, okay, just create one more method, and I believe this is going to be last method I'm going to create, and I will say close. All right, and then this will do nothing, but it will just do connection dot close. We are good with this. We have created all those methods which we are going to use on this RabbitMQ configuration. We have all these methods, reusable methods, right? And then what next we are going to do? So let's go back in architecture diagram, and we can see here we need to create a server, right? So that our client can order something. So I will go back here, and very first thing what I am going to do here is I will just create a couple of things over here. I will create what we need to create. Okay, before creating server, let's create all those methods, all those functionalities which we are going to use, which we are going to align in on a single file, or which we are going to align and make them work. Because if you will talk about the real scenario, all those RabbitMQ staff, delivery boys, or cashier, or kitchen chef, right? They all are aligning at the same place, and then the finally pizza shop is they are making this pizza shop work, right? So that's what we need to do, correct? And so for that, what I'm going to do here is I'm just going to say, okay, create a handler function, so that we'll open we can open basically what we can say, create a handler function so that we can open a connection to the client, to the user. We are giving a passage to the user, so that user should be able to order. We are going to present an interface to the user, so that using that, user is going to put order to our pizza shop. So for that, I'm going to create one folder over there, and I will call this as a handler. And this handler should have two files. One is for connecting using HTTP request, and then user can connect with WebSocket as well, right? So very first thing, I'm going to create this file with name order handler, and this is going to use for HTTP. Of course, we are going to create a RESTful API. So I'll say, okay, create this order handler, and what this order handler will do. So I'll say package, very first thing first, and I'm going to say type order handler, I'm sorry, and then I'm going to use struct. So this will have a couple of things, but then we need that things over there. So let's create that things basically, and then we'll use that. So I'm going to create one more folder here, and this time I will say service, right? And then this service will have, now think this way, if we'll go back in our architecture flow, here we can see there is someone who is publishing this order, publishing this event to the queue, or publishing this message to the queue. And who is that? Of course, RabbitMQ. So RabbitMQ is acting as a publisher, so it is publishing those messages or orders to the queue, correct? And then there's consumer as well, right? So RabbitMQ will give access to consumer as well, to consume for those messages or orders which RabbitMQ put on the queue or put on their to-do list. So RabbitMQ will say, okay, I'm giving you access to this specific queue or a specific to-do list, so that you can go every time in this queue and check for the messages. If there's any message, you should be able to pick that message. And in this case, order. If there's new order, or if there's any order which is there in the queue, which is there in the to-do list, you just start consuming those orders, right? So same thing we are going to do here, and for that we need two different things. One is publisher and there's one consumer. That means one who will publish the event. Of course, RabbitMQ will be publishing the event, and then the consumer who is going to process those events, process those message or process those orders. So for that we just need to create two function over here, and not function, two file. I will say, let's say message, and then I will say processor. Not processor, processor will come at the end. I will say publisher. Alright, publisher dot go message publisher. Let's add service as well, suffix, so that we can know, okay, this is a service class, implementation class, not class but struct, of course. But the thing is, which the way which we are following here is totally based on the solid principles. Every file should have their own responsibility. Every file should have a concept of interface, and we should be able to substitute those interface type at runtime, and then we should be able to, you know, achieve polymorphism. So that's the concept of solid principles, right? So that we are going to follow here in this, and every module which we are going to create, each low level module should not depend on, basically low level module and high level module should connect with each other using interface. There should not be a direct connection, right? So that later if you want to change the RabbitMQ to something different, let's say tomorrow you are going to use Kafka, you should be able to do that easily, because your high level module, high level is nothing but the above module who is acting above your current file, or who has less, you know, who will just care about the function, not the implementation, right? So if they want to contact to the low level module, so low level module should not actually, it should not depend on low level module, right? There should be an interface to talk between them. So without talking, let's see how we can do that. So I'll say package service, and then what I'll do here is I will just create one interface. And how can we create interface? We know that in Golang, and if you're not aware of that, please do watch my Golang series, Golang playlist, and you should be able to understand that very easily. I explained everything in very detail. And I will say, okay, this time I'm going to, okay, whatever interface we are going to make here in this video, I'm just going to name that interface with the prefix I, so that I should be able to understand, okay, this is interface. All right. So I'll say I message publisher. If you want to name this in a specific way you want, you can of course do that. Feel free to do that. And then, but the thing is, at the end, the functionality should be, the name should be as per functionality, right? So I'll say interface here, and then I should have a publish method here. So anyone who is going to use this interface will have to implement this contract, will have to agree on this contract. Okay, I will be publishing, I have the capability of publishing the event as well as creating a to-do list. Then only I will be a message publisher. Otherwise I won't be a message publisher. Okay, so we are doing the same thing over here. I will say publish event, and then I need queue name. So where you need to list those orders, right? You are creating a queue for orders, so that should go inside the orders, not the other queue, correct? We can have n number of queues. So I'll say queue name we need, and then I need the data as well. So what kind of data is needed? I will say empty interface. Why? Because this should be an interface, right? It should not be coupled to low level module, or low level module should not be coupled to high level module. All right. Sorry. And then of course this data should be, this order should be there in place of data in this case. And then I will say, okay, it should have a declare queue as well. Since I am the publisher, I want to publish this message to a specific queue, so I should have access to declare queue as well. So I'll say queue name, and then it's going to be string. But then this will return error as well, and this function will also return error if there's any error. All right, we are good with this. Now we are done with this declare queue. We have this contract ready, and whoever is going to agree on this contract, whoever is going to implement this contract, is considered to be as publisher, right? So I'll say message publisher. This time I'm going to use RabbitMQ. So I'll say RabbitMQ can be a publisher, right? So I'll say conf, we need a configuration, and then I will say, okay, this conf will actually come from where? We need that, we know that we have created this configuration, RabbitMQ configuration in config package, and then I'm going to say, okay, I'm going to use the same RabbitMQ connection which we have created over there, right? And then I need one more thing, mutex. And why we need mutex over here? That's a big question. Actually, that is not a big question, but it's very easy. So think about this. If you are calling someone, right? If there's a one channel through which you are calling your friend, now if some other person is going to use the same channel, what will happen? You have created a channel, you are going to talk using that channel, you are going to convey your message through that channel, but then someone else can also do that. Someone else can use your channel and then send their own message. So in that case, what will happen? You will have your own message as well as they will have their own message in a single channel, and that should not be the expectation, right? So for that we are going to say, okay, at a time either I should be able to communicate through this channel, or you should be able to do that. That means any of the single person is going to communicate through the channel, right? So for that we need to say, okay, when I am talking, I will block this channel. So I will be using this channel, no one else can use that unless I am going to free this channel, unless I am going to, make it available for you. So when you are going to use this, of course you will be locking that as well, and then I should not be able to access this. So that's the concept of using this mutex. Mutex will lock the specific resource, and it will wait for the resource to be unlocked once the functionality is done, right? And then we need a couple of functions on this message publisher. So of course we need to implement this, we need to agree on this interface. So for that we can say, okay, let's register this function on this message publisher. So I'll say MP, short format for message publisher, and then I need a pointer to it. So I'll say message publisher here, and then I need to implement this method. So I'll just copy it from here, and if interface has to be implemented, you have to implement all those methods which is present on the interface. That means interface says, if you want to agree on a contract, if you want to agree on my contract, you should have to agree on all those points which I have listed over there, right? So I'll say, okay, fine, that is completely fine, I will be agree on that, and then I will start my own implementation. Message publisher interface says, I will just give you contract, you can have this basic contract, and then on top of that you should be able to implement your own contract. So I'll say, okay, let me implement my own contract, and in this case I am going to use a channel, and using channel only we are going to send data, right? So we'll say, okay, give me the channel. So I'll say mp.conf is nothing which this RabbitMQ configuration, and then I will say get channel, right? And we have the channel, and finally we are going to say, okay, we have channel, and let me just check for nil. If channel is nil, just return error. So I'll say, okay, fmt dot error of, I'll say error of, and then I will say message channel is nil, please retry. All right, so you can put any message which you want, and then I will say finally, okay, just declare this queue. If queue is not there, not queue, this time I'm going to say, okay, not channel, it should be actually, first we are going to declare this queue method. So I thought we are implementing the queue method. So I'll just copy paste this here, and then I will say, okay, if that is the case, then just call this channel and create a queue, new queue. So for that we know that we have a function queue_declare. So queue_declare we will be calling here, and then we need to pass a queue name, and then it should be persistable. That means we already know that message should be persistable if we want. If we don't want, you can omit this, we can make it as a false. So I'll just pass false, and then finally I'll just pass nil. We don't need these arguments. Alright, so we are done with creating queues, and if there's any error, I will just return this error, because this function will return error. Right, we are done with implement, not nil, it should return error. We are done with this function. Now finally we will implement this publish event function as well. So let me just move this to top, because this way it will look much better. In this is nothing to be this is nothing related to any order. This is just to make your code cleaner. And here I will say, okay, just register one more function on this, implement one more function on this specific struct, and this time of course this is going to be message publisher. So I'll say message publisher, and then I'll just copy this method signature. I'll just copy this contract, you can say, and paste it over here. So basically we are saying okay, I'm going to agree on your contract, and I will put some more custom implementation of my own contract. Fine. And then very first thing what I'm going to say is, okay, I will be having data, and what I will do with this data is not data, it should be, let's make it body. Body means data, of course, and I'm going to use body over here. So now I'll say data is, of course, I'm going to assume this data will be, pure data so that we can use it. I'll say okay, json.marshal. And this Marshal is one method that is defined on JSON and JSON package, and this JSON.Marshal is expecting an object of type any, and then it will give you a byte of that data so that you can pass those data in different channel, right? So I will say okay, I have body over here, I will pass this body to this Marshal function, and if there's any error, let's check for the error as well. So I'll say if there's any error, just return the error. So I'll return this error because this function is expecting to return this error as well. So next what we need to do is we need to get a context. And why we need a context? We need a context to perform certain operation, and basically using the context we can have more control on the specific functionality, and the control is of course related to the timing. So in this case I'm going to say okay, use this context package and with timeout. That means this function should get executed within this much of second, or else it will just time out. That means this function will it won't work anymore. So I'll say okay, just use the background context for now. Parent context is going to be background, the main application context, and then the time which is it's assuming to be. That means this function should get executed within this frame of this time, and I will say let's say 15-second maximum. So time dot second I will put over here. Okay, now this function should get executed within 15 seconds, right? That means not within, but it should get executed fully until 16 seconds. And then finally I'm going to say okay, if that is the case, then we need to cancel the function, cancel the execution of the function, right? Now what we need to do here is I will just check for the queue name over here. If queue name is going to be empty, alright, that means there's no queue in that connection. So I can say okay, queue name can be, or if someone is not passing a queue name over here, so I'm just going to use a default queue for this. And we know that, how can we take that? Using this config.getEnv property, here we are going to use RabbitMQ and default queue. So using this we will be able to fetch that default queue from the env which we have already defined in config, right? So we are good with this queue name. Now we have finally queue name, then we need a channel to communicate, right? So I'll say channel, and then we have message publisher access over here. So I'll say use this configuration, and we know that on this configuration we created a function get channel. So I will use this channel so that every time we will get a new channel. Let's check for the validation of this channel. I will say channel equals to nil. So just panic, because if channel is nil, you should not do any operation now. And I will say just close this application. So for that, I'm just going to put some message so that we can be able to track those message from the log. And here I'm going to say message channel is nil. So retry. All right. And then I'm going to do one more thing over here. I will say, okay, if channel is closed as well. So if channel is closed, so we have closed function as well over there. And I will say, okay, in that case also you need to panic because you have tried more than once. All right. So I will say could not publish event, could not publish event, or you are not able to put those order onto that to-do list. So we are going to log you should say something to us so that we can know, okay, what happened over there. So I'll say could not publish event, channel is closed, because channel was closed. So we should RabbitMQ is not able to put those orders or messages onto their to-do list. Fine, we are good with this. And if that is also passed, then we will say, okay, just use this log, and this time I'm going to say creating new channel, just to if we want to see all those logs whether it is working in expected way, we should be able to see that, and we should be able to debug it more easily. That's why we are putting all log everywhere on each of the line. So I will say, okay, created new channel. In this case, every time we have created a new channel, right? So I'll say created new channel, and then I can say just put the address of the channel. So we should be able to match, like, okay, this channel has been created, and then this should get closed as well. It should not keep open indefinitely, right? So here I'm just going to print the channel address. And how can we do that? We know that using address operator we can be able to access the channel. But then what is the issue here? We cannot do, since this log function is not expecting more parameter. So of course we need to pass this inside a printf function. So I will to cut it from here, and I will say use fmt.printf and then paste it here. Now this is completely fine and legal as per Golang. We have created a new channel. Next, what we need to do? We have channel access. We know that we can publish message using channel. We can send message using channel. And then we have error over there already. Do we have? Yes, we have. So if we have error, what we are going to say is, okay, why this is showing error? Context. That is fine. Okay, we'll use that context over here. So I will say error, and then I will say use this channel, and then this channel will have a function publish with context, so that if there's something wrong, this specific function is going to take more time, this context will get cancelled after 15 seconds, right? So that's why we created context over there, so that we will have more control over a functionality. So I just pass this context, and then we have to pass a couple of more property over there, which this publish with context is expecting. So this time I'm not going to use any exchange, because you can see here first parameter is context, and then it is expecting exchange. That means if the message is not delivered, it should, or not delivered not, but if message has to go on a specific queue or a specific path or a specific to-do list, then this can be used to route those messages to a specific queue. For now I'm not going to use that. If you want, you can play with that, and you should be having a better idea on that. So now next parameter is going to be the queue name. Of course we need to publish this message to a specific queue, right, a specific to-do list. And then I will use false. That means mandatory, it's not mandatory. And then immediate is also not mandatory. And finally we need a publishing object over there. For that I'm going to use mqp091, which is of course package name, and then I will say publishing. So now this publishing is expecting something from us, and what is that? So let's see how it is, what it is expecting. So okay, it's expecting data type. That means this data type should be in a specific format, data should be in a specific format, and here I will say okay, this format should be application JSON, right? The same way we are defining in API, REST API, right? Same way we have to say here as well, okay, this message which we are publishing from here, which you are going to use this message to publish, it should be in a certain format. So basically what this RabbitMQ will do, when RabbitMQ is going to put those orders onto a queue or onto their queue list, or you can say to-do list, it has to be in certain format so that this consumer should able to understand that, right? So for that we are going to say okay, content type will be JSON, and then the body is nothing but the data which you are going to publish, and this body is expected to be of type byte, array of byte. That's why we have converted those data to a byte. So I'll just pass this data over here and we are good with this. Now we need one more thing. I will say delivery mode, and delivery mode is going to be persistent. Alright. So I will say AMQ dot persistent. You can use transient as well if you don't want to persist that delivery mode. So let me just use this persistent, and you can of course play with that transient and other option as well and see how it works. So that's the best way of extracting the information. So we are good with this. We are now published the data to the RabbitMQ, right? And then we will be checking error as well. So I will check error not equals to nil, right? And if it is not nil, of course we are going to return the error, because this function is actually expecting to return some error if there's any error. And if that is not the case, so I'm going to use logger.log. I'm going to put certain message over there. Okay, you are done with this channel, you have successfully published this message to the channel through this channel, and then you need to cut off, right? You need to close this channel as well. So for that I'm going to say okay, just print a message in a specific format, and here I will say event published. Let's say I will say event published, and what was the event? So I will say okay, event was nothing but this body which is coming inside a parameter of this function, the actual data. Alright, so that we can able to see those data on the console as well. And then if that is the case, I will just close this channel so that it won't leak resources. That means the channel won't be there anymore. And we are good. Now we are going to copy paste this message here as well, and this time I'm going to say here is channel closed and channel closed, right? Channel closed. So this is completely depend on you if you want to show this message to the console, so that user will able to, those who is using this application should able to know okay, this is what happened over there. So they should be able to debug this very easily. That's why we need to put log, or we need to maintain certain structure. All right. So here what I'm going to say, okay, channel closed, and then of course here I'm just going to put the address of the channel once more, so that we should be able to verify by seeing logs, okay, this specific channel has been created, and then it must be closed once this functionality is completed, right? And if it is not closed, means of course there's resource leaking, that means memory is leaking, that channel is empty somewhere in the memory, and due to that channel your program will get slow at certain point of time. So that's why we are closing those channels, and then finally I will say okay, if there's no error, everything worked fine, I will just return nil. We are done with this two contract implementation. We are agree on this two contract as a message publisher, and in this case of course RabbitMQ is the message publisher. Now the benefit of using this, later on if they want, if we want, we can change this RabbitMQ to something else, let's say Kafka or something else we want, right? So we should be able to modify this function, and everything will work in expected way, because everywhere we are going to use this method, not this actual implementation. That's the concept of interface. So I will say okay, get me a message publisher. So I'll say get message publisher service. So this is service, of course, and I'm going to return message publisher here, and then I will say RabbitMQ. It's expecting a RabbitMQ connection, so I will say RabbitMQ MQ conf, and then it is going to be coming from, it is going to come from config, and we know that we have created a method over there, get new RabbitMQ connection. So it will just give us a connection object, not connection but the RabbitMQ connection type which we have created manually, and then I will say just return the address of this message publisher. Alright, so here it should have a configuration, and then I will say RabbitMQ conf. Fine, we are good with this. And what else we need over here? Do we need something? No, we don't need, we just need a mutex over here. And do we need to lock it here? And the answer is no, we don't need to lock it here, because in this case every time we are using a new channel, right? So if there's a new channel, that means of course that channel should not be locked. It's already new channel for the specific workflow or specific Go routines, right? So we'll see how we can launch Go routines, and then this channel is, you know, we should basically synchronize this channel and it should work properly. So I'm just going to remove this for now, because for now I'm not going to use that, so we don't need that actually. And we are done with publisher. Now next thing, we should be implementing consumer as well. So I'll say message consumer and just use suffix as service.go. So what this message consumer will do, it should be able to, you know, access all those messages which RabbitMQ published on their to-do list, right? Which we saw here, RabbitMQ is picking all those orders and try putting all those orders on the message queue, which is nothing but a to-do list, right? So let's create a functionality for consumer, so that kitchen is assumed to be a consumer, so kitchen should be able to pick all those orders, right? So I will say okay, first thing first, this should be a service package, and then similarly we need to create one interface over here. So anyone who is saying I want to be a consumer, kitchen is saying I want to be a consumer, so kitchen must implement this contract, right? So I will say okay, message consumer, I can say consumer and service, and this is going to be interface of course, but then we should have a declare queue method, because as a consumer also I should have access to queue method. Let's say at certain point of time there's no queue, so I should have access to queue. I should be able to create a queue or to-do list, and I will hand it over to you, to the RabbitMQ, and you will start putting order on that queue, right? So for that, if you don't want to register this contract over here, you can remove this method. We don't need actually. So I'll say queue name, and then I will say string, and this will return error, right? Next, we saw in publisher we have publish event, and then here in case of consumer we should have method to consume the event, right? But then queue method is going to be same, right? So I'll just copy this from here and paste it here. Let us go okay here. Now it should not be a message publisher, it should be a message consumer. So for that I'm going to say okay, just create a message consumer type. So message consumer service, and of course in this case it is a kitchen if we'll compare it with our pizza shop, and I will say struct, right? Now this struct will have the same thing, that is config, right? And this config is coming from where? This is of course coming from the configuration which we have created. So configuration package dot and RabbitMQ connection. RabbitMQ connection, cool. Okay, we have this message consumer service, not the message publisher. I will say, okay, just register this functionality or agree on a contract on this specific message consumer. So I'll say message consumer service, and then this should also be imported. Fine, we are good with this declare queue, and finally we just need to implement this consume event. And how can we do that? I'm going to say, okay, create one contract or method, consume event and process. Since you are going to consume this event, kitchen is going to consume this event. Let's go back in our application architecture diagram, and there we can see order will come, RabbitMQ will pick up those order and put it into message queue, which is to-do list, and then this consumer should be able to pick up those order, and then internally this consumer will have multiple chef, right? This kitchen will have multiple chef, and in the context of Golang, of course, we are going to use go routine. We are going to say, okay, for a specific message, launch one go routine, and we will see how we can do that. That means why we are going to use go routines. Let's talk about that. So we can do that on a specific kitchen. That means that a specific single go routine as well. That means always think this go routine as a chef. We already know that, we assume this go routine as a chef. So if there is a single chef, right, we don't have to use multiple go routine. That means there won't be multiple chef. Only one chef will be handling all the kitchen work. He will be creating toppings, he will be creating cheese, he will be creating dough, and then finally the pizza he will be creating, right? He should be able to do all those things, correct? But then there will be a problem, because at a time this consumer, this kitchen will have lot of order, because we are not blocking user, we are not blocking customer to stop putting order. As a customer, he can put order anytime. We are not blocking that order, right? And if the order is coming, then RabbitMQ is of course not blocking that order to put it on message queue or to-do list. So we know that once order is there available in the message queue, consumer will consume that order, right? And if there will be lot of order, then this consumer will have only one chef. And just think about the scenario, if there's only one chef in the kitchen and there will be lot of order, right? Then order processing will be always slow, correct? Pizza making process will always be slow. So how can we tackle those issues? How can we fast up those process, right? So we can do one thing, we can add more chef into the kitchen. So as many as chef will add, will process all those order very fastly, right? Same thing we are going to do here. For each of the order, each of the messages, we are going to appoint a new chef every time, and this time this chef is nothing but a go routine. Now you understand, right? So every time there will be a message, every time there will be an order, we'll be launching a go routine to handle those messages. Now there will be one more problem here. Let's say there are a lot of orders, then as a kitchen there will be lot of chef, which is of course not efficient, right? None of the shop will have n number of chef, right? There's a limited chef, and all those orders should handled by those chef only. So we can put certain rate limit on that, and we can say, okay, we have 5 chef only, and this 5 chef should be responsible to handle or process all those orders, right? So that also we can do here, but for the simplicity, I'm just going to appoint n number of chefs to handle all those orders, so that processing order will be very quick. Let's go back to code now. We are now going to implement the same thing in the code, right? So I'll say consume event and process. If you consumed it, you have to process this, right? So for that, I'm creating this consume event and process. This is just a method name. If you want to name it something else, you can of course do that. And this should be a string. And here I'm going to say processor. Now processor is nothing but it is going to be a message processor. right? Which will process this message, and that message processor is nothing but you can call that as a chef. We are going to appoint this message processor. We'll handle this, we'll pick up this specific order and give it to a processor, give it to a chef to prepare those order, right? Similar thing we are going to do, we are going to implement in code. So how can we do that? We don't have chef yet. So let's create a chef now. So I will say, okay, that's fine. Let me just create one more file over here, and I will say this time message, and I will say processor service.go. Fine. And then here, what very simple thing I'm going to do this. I'm not going to implement that all functionality now. We will implement that after we are done with the consumer. So at least we should be able to call that functionality. So for that, we'll first thing first, we are going to define this package name, and then I will say, okay, anyone who has power to process this message, who has power to bake pizza, will be appointed as a chef. Correct? So for that, I'm going to say, okay, just create a message processor. I'll say message processor in this case, and assume this as a chef. So it has access to process it. It has access to, bake the pizza. So I'll say message processor, and it is going to be a contract, right? So we know that anyone who is implementing this should have this functionality. Then only they are going to be said as message processor. They are going to be said as chef. So if chef is not having, chef can't prepare something, then how can we call that as a chef? So I'll say message, and then we'll be receiving the message, right? We are done with this creating interface, and then finally we will say, okay, I will have now the chef here. This chef is going to actually agree on a contract that I should have a process message, or I should have power to create pizza. So we just created a chef now, and then finally I will do func, and before implementing all those methods, I will just say get message, and I will say get message processor service. Fine. And I will say publisher. In this case, I need a publisher as well, because let's go back to architecture, and here we can see message will get picked up, or it will handed over to the go routine, or it will handed over to the order will handed over to the chef. But then chef should be able to publish those message once more to the RabbitMQ. That means chef should be able to say this to RabbitMQ, okay, I am done creating this order, I am done preparing this pizza, collect this from here. There has to be some communication, right? So that's why we need a publisher there, so that publisher access there basically, so that this using that publisher, this go routine will say, okay, we are done creating this, we are done baking this pizza, right? So similar thing we are doing here. I will say, okay, now this time we are not going to use, as we talked before, we are agreeing on a contract. So we are not going to use the implementation. Instead, we are going to use message publisher as an interface, right? And then we need one more thing over here, but that I'm not going to add now, since at every time when order stage is going to be changed, we need to say it to client as well. Like we need to send the notification to client, to user or to customer, that your order is being prepared, your order is ready, your order is ready to picked up, right? So we need to say this to client, we need to say this to customer. So we will say that later. First let's implement this order processor, and I will say it is going to return message processor. Message processor. Alright. And this message processor is of course expecting two things. One is publisher, so I'll say publisher, and it is going to be iMessage publisher. The contract, of course, interface, not the actual implementation, so that we should be able to change that later very easily. And then it need to have one more thing, connection, of course, that is related to the WebSocket connection through which we are going to notify back to the user, but that we are not going to do it now. So I will say, okay, that's fine. This time just go back to message consumer. First we need to, okay, before that let's do that. And this time I'm going to say, okay, I need to have certain things over here. And what exactly is that going to be? So that is going to be a connection. So using that connection, we are going to send the notification to client, and that connection is of course going to be a WebSocket connection. We know that. Let's go back in our architecture flow diagram, and we see that here notification has to reach to client or customer through WebSocket, right? So let's create a WebSocket service as well here. WebSocket, I will say WebSocket, not like this, WebSocket, and suffix is going to be service.go. So let's create this package, and I will say service, right? And here also this time we are using iGorilla, sorry, this is Gorilla WebSocket. And then later if we want, we can change, we should be able to modify it to something else, different package. So make it an interface, make it a contract. So I'll say iWebSocket, WebSocket and connection. And this is going to be interface, of course. And now this interface should have, so who is going to agree on this contract? So anyone who has access to, who can send message basically. So who can send message, and this will have message. And now the data which we are sending back to the WebSocket connection, it needs to be an array of byte. And then I'll say if there's any error, it will return error. Now it should have a functionality, it should have a function. Anyone who can receive the message as well is set to be as, set to be as a WebSocket connection. So, and it will return the array of bytes, since data will be coming in array of byte as well, but then error will also be there. Now we should have a close method as well. So this is all condition, this is all contract we make, and then someone has to agree on this contract. So of course this time Gorilla is going to agree on this contract. So I will say okay, WebSocket connection, and it's going to be struct in this case. And finally what we can do here is we can say, okay, now we need one thing over here, connection, right? And this connection is of course going, we know that this connection should be a Gorilla connection. And how can we do that? We have this package Gorilla WebSocket, we are going to import that, and then on this package we have connection object. All right. And in case of message connection, so whenever we are going to use this message connection, we should, the same concept appears here as well, because as per Gorilla documentation, this we should have a single communication connection. So basically when a customer or client will connect through WebSocket to our server, we should be able to send message in a same WebSocket, right? And if someone is going to use the same specific connection, that means multiple Go routines or multiple functionality is going to access same Go routines, so same, not Go routines, but the same connection, same WebSocket connection to publish the message, send the message to the client, send notification to the client, then there will be a rest condition and all those messages will get passed into the same connection. That is why Gorilla is not allowing this to happen and your application will crash, right? It is not thread safe actually. All right. So basically when you are dealing with Go routines, that means you have a different hand, you have different safe, multiple safe, And what if multiple chef will try to send message in a single channel, in a single connection, right? So that means you can say you have two customer over there, and then both the pizza is going to send to a single customer. That is not right, of course, right? So for that we are going to say, okay, use it one by one. If I am using it, means I will only use it. None of the above resource will able to access that until I will free this resource, until I will make this connection free, right? And the same case applies to me as well. So I will say, okay, use this mutex now, and then we are done with creating the WebSocket connection. We need to have this method over there. So what I'll do here is I'll just copy this here and paste it here. And then we need to have the method. This method should be present on this struct. So for that I'm going to say ws, and it should point to the WebSocket connection, and we are good now. So what I'll do is I'll just copy paste this so that we don't have to type more than once. I will once again cut from here and paste it here. Now we have all those contract which this Gorilla has agreed upon, right? What happens? Okay. So I'll just cut it from here and paste it here. We are finally done with this WebSocket connection. We should have implementation of this. So the implementation is of course very easy. And what is that? So we will say, okay, just lock this resource. If someone is going to access this, use this resource, just lock it for the specific user or for the specific chef go routines, right? So, and once they are done with this, just unlock this. So I will say, okay, unlock this as well once they are done. And finally I will say return ws.connection dot connection dot, in this we need to send the message. So we will say write message, and then message type we are going to send textual data. So we'll say WebSocket dot text message. That's the constant present on the WebSocket package. And finally we need to send the message. So we'll say, okay, let's pass this message over here. Till here we are good, right? We created a send message function so that using this WebSocket connection we should be able to send the notification or send the message back to the customer or client or user. Fine. Next, receive message as well, we need to lock this before, and for that I'm just going to copy this, paste it here, because same code we are going to use it here. And in this case we need a message from the client, right? So that we should be able to read that message. I will say, okay, connection dot read message. Do we have read message over there? Yes, we have. So message, and then it will have error as well. So it will say error, and we know that we are going to return message as well as error. So we will say, okay, return this message and then error as well. Fine. And finally we should be able to close the connection. If you are done with sending those messages, if client is done with sending those messages, there should be a way to close the communication, close the connection, right? So for that I'm going to say, okay, ws.connection.close, simple. Fine. Now we need to get this message WebSocket connection, not message but the WebSocket connection, and for that I'm going to say, okay, new WebSocket connection. Fine. And this should have a connection, so I'll say connection. So use this WebSocket, not WebSocket, small WebSocket, WebSocket.connection. So I will say, okay, I will return you WebSocket connection object, not object but the struct in this case. So return, I will just return the address of this WebSocket connection, but it need this connection, so I will pass this connection which is coming as a parameter over here. We are done with this, and then we are going to use same over here. So we know that we have create and process, not create and consume and process, and there we need this WebSocket connection. So we are going to say okay, but before that we need certain things. How can we say that? Okay, before that we are going back in a processor. So processor need that actually. So what processor is saying, okay, you gave me this publisher, I can publish this message to to-do list or to a RabbitMQ queue, right? Both are same only, we just assume that as a to-do list. So you just give me one more thing so that I can notify, I am able to notify this to RabbitMQ, but then I should be able to notify it to the client as well, right? Or to the delivery manager, or not delivery manager, but delivery boy or someone else, that okay, this order has been prepared. So give me a way to for that. So I will say okay, I am going to give you a connection object, right? I am going to give you a connection object, and that is going to be a WebSocket connection. Using that you should be able to say to the specific customer, right? And this time I'm going to say it is going to be map of string and then WebSocket connection interface. Fine. Now we need to have that connection here as well. So I will say connection, and this time I am going to use the same thing because we are going to use the same WebSocket connection every time in this example. So, but in reality we'll be having lot of connection inside this map of a string and then connection, because we are storing the connection in this map, and then we need to access those connection and we need to specify a specific customer. But for the simplicity of this application, I'm just going to use a single connection over here so that we can streamline all those process, and I should be able to make you understand it in easy way. So we are good with this, and then message processor should have a mutex as well here. So I'll say mutex, and this time also it is going to be sync dot read write mutex. All right. Now we have this, and then we just need to return it from here. So how can we return it from here? We know that we just need to type return, and then I'm just going to return the address of this specific message processor. So just return the message processor, but then it requires connection as and publisher. So let's provide this publisher, and I will say publisher connection also we have this time, so I'll say connection. Let me just save this, and this is, you can see here, this is the beauty of injecting object, and this is how you can loosely couple your code and make it highly flexible, highly modular, and this is the concept of dependency injection as well. So you are learning all those things in a single tutorial. So we are good with this, and then we are going to use this message processor over here. So I will say okay, you need a processor as well, right? Because you are consuming event, then someone has to be there to process that, right? Chef has to be there to prepare those orders. So I will say okay, I will give you the access of this, I will appoint a chef for you. So I'll say processor, and then I will say okay, this is going to be message processor, and of course in reality it is going to be safe, right? So we are good with this function method signature, method contract, and then here we are going to say okay, just implement this func, and then I will be saying here okay, just register this, implement this functionality on the specific struct. So this time it is messaging consumer service, and then this method. So this method should return something, right? This method should return some error if there's any error. So I'll say return error as well, and I will copy this from here, paste it here. We are good with this all implementation. So in this function, as the name suggests, consume event and process, it will pick up all those orders from the to-do list of RabbitMQ, and this then start processing it. That means it will start handling those, it will start sending this order, assigning this order to a specific chef in the kitchen. That's what we are going to do here. So I will say okay, for that I need a channel, so that using this channel I should be able to listen or consume that all messages which is there present on the message queue or order list, right? So I will say, okay, get me a channel, and we know how we can get a channel using configuration. So I'll say, okay, this is not going to be MP now, this is going to be message consumer. So I will say consumer service, message consumer service MCS, and then here also we need to use MCS, fine. And then here also we need to use MCS, so that everywhere the code should be neat and clean. Now we need a channel, so for that we can say mcs.conf.get me a channel. We have this functionality available, we created this at the beginning, and we'll just check this. If channel is going to be nil, in that case what will happen, it will just return the error. And what is going to be the error? Of course we'll just format this error, and not format, we'll simply say, okay, messaging channel is nil, and I will say retry, right? There's no messaging channel, so you won't be able to consume the event. But there's one good thing over here, even though there's no consumer, right? Consumer may be busy this time, that means all of the chef is busy in creating those pizzas, right? Still our application should be able to accept all those orders. RabbitMQ should be able to pick up all those orders, and then of course we know that RabbitMQ create a queue, and then RabbitMQ is going to mention all those order, list all those order on a specific list, to-do list or message queue, right? So once this consumer is ready, that means consumer will again start consuming this order. That means if staff is again back, right, chef is again back to the kitchen, then they will start preparing those orders once more. So that's the benefit of using this RabbitMQ messaging system, RabbitMQ broker messaging system. All right. So anytime when the consumer is not available, message will be there as it is until the message is acknowledged. Basically, when message will go here, then consumer will say, okay, I acknowledge this message, not consumer. Consumer will say, I will acknowledge this message. Then you can delete this message from your list. That means I am done processing this order. I am done creating this pizza. You can delete that order from your list. That is no more required. We'll see that next. So here I'm going to say, okay, message channel is not empty. So I'm just going to put certain log over here so that we can see, okay, what is happening over there. So I'll say consuming, and then I will say message. Fine. So message consumer should be only one. It should be able to pick all those messages, because we know that kitchen is going to be one single kitchen. But inside those kitchen, inside that kitchen, we can have n number of staff, we can have n number of chef, right? But kitchen will always be one. So that's why we are using a separate channel for a kitchen. That means a single channel for kitchen, and then separate channel for all those workers or staff or chef. So I will say, okay, now start consuming the message. So kitchen says, okay, not kitchen, but consumer says, okay, kitchen, of course, it will say, okay, using channel, I am going to consume all those messages, and on channel, there is a consume method for that. So now this consume method is expecting queue. So from which order list or from which queue I need to start taking the order or the messages. So next I'm going to say it is going to be empty. I don't need a specific consumer to be there. So if I'll mention a specific consumer, that means only those specific consumer is going to pick this message. All right. So I'll say empty. That means anyone who want to listen for this message, who want to consume this message or prepare this order, should be able to prepare this order. All right. So next I'm going to say false, because we don't have to be exclusive over here. I will say false, and false. What else we have? So I'll say, okay, we have no wait, of course, no wait, false, and then I will say nil. I don't need any arguments over there, so I'll just say nil, and then we are able to get all those messages. We are able to pick up all those messages from a to-do list. Let's check for the error, if there's any error reading the message. So I will say, okay, if there's any error, just return fmt dot error of, and then failed, I will say failed to consume message, right? Consume message. There's some problem between the kitchen and then the order list. I'm not able to, as a kitchen, I'm not able to access the order list, or there's some issue due to which I'm not able to see all those orders, right? In that case, I will say, okay, failed to consume message, and then I'm just going to use %w in this case, and I will just say error. Fine. Next, what we need to do is, we are done with consuming the order. That means we have all those orders here. We have started consuming those messages, those orders, right? Now we have to start posting this, or we need to start assigning this order to the chef, so that chef would be able to process and bake pizza. For that, I'm going to launch one Go routine over here. All right. And then why I'm doing this, because when I will be iterating over these messages, this message is actually giving you a channel. You can see here channel of delivery. That means you will be having a lot of messages coming, and that message will come asynchronously, right? So for that, it is not asynchronously, but it's a blocking way. So if I'll iterate over these messages, then the code will get blocked. So for that, I'm going to say, okay, wait until this message is done. And for that, you can use select in Golang. Or else, if you want to use different thing, of course, you should be able to use different thing. And in that case, you will be using wait group as well. So, but for now, I'm just using this select for the simplicity. And you can, of course, use this. There's no issue with that. So I'm just going to launch this Go routine, and basically this Go routine, I'm going to say, okay, this Go routine will have access to the message, not here. It will just call this way. Okay, now I will say, okay, I'm just going to start picking up all those messages. So how will I pick up those messages? We know that we have list of order over there, and the order is coming inside a channel. We know that in Golang, we can iterate over channel to listen for the message, or yeah, for listen for the message from a different Go routines, right? So I'll say, okay, just iterate over this channel, and then now you are done with picking up the specific order, and then you need to launch a Go routine, or you need to place all those chefs in a kitchen so that each chef can work independently. And for that, of course, in Golang, we have concept of Go routines. So I will say Go again, and then func, this is if function, of course, which is immediately invoke function, and I will say message, and then this time this is expecting AMQP delivery. Why we are expecting AMQP delivery over here? Because this is delivery is nothing but the message, actual message, which we have picked from the list, that will contain not only the order details, but that will contain behavior as well. So we'll pick those messages, and right, so we will pass this message here to this Go routines. Okay, now this Go routine is nothing but a specific chef, and we know that we can have n number of chefs, and for that we used this inside a for loop for each of the messages, right? And why we are doing that? Because we already talked about that. Let's say if you are going to use a single channel to send the message or publish the message, right? Then multiple resource, multiple Go routines is going to access that channel. That means you created a channel, you are going to call your friend, and then multiple listener can listen for your call. that is not the good way, right? So each person should have their own call, should have their own mobile phone to make a connection. So that's why it's the same concept appears here as well. Same concept applies here as well. So basically each uh, chef should be able to process that order independently. They should not be dependent on each other. As you can see here, RabbitMQ is not dependent on consumer. Consumer is not dependent on chef. They are just passing these things in place so that each of these entity, each of this person is able to work independently, and that's the beauty of using RabbitMQ. So basically you are maintaining the event based architecture. All right, so let me just go back here, and then I will say, okay, based on certain events you are again going to perform certain events. So that's what we are doing here. So I will say, okay, I have the processor, so just assign this message to a specific chef, or assign this order to a specific chef. So but the chef need order. Now you can provide this actual order over here, and you are good to go. So finally you have handed over this order to the chef, and then you just need to check for error. If there's any error not equals to nil, we are just going to log the error, and we will see what error exactly is there. So for that I will be using this logger.log, since this should be the configurable things, and whenever I need that time only. So I will use sprintf, and this time I'm going to say message processing failed because of some reason. So I'll say message processing failed, and the reason can be anything. So I will say value, and I will console that value, error. Fine, we are good with finally handing over this order, a specific order or message, to a specific chef, right? Now as many as message we will have, we are launching as many as go routines, and of course we are hiring as many as chef, right? And then if you want to limit this chef, you want to rate limit this chef, you just try it yourself, limiting this rate limiter, applying this or implementation of the rate limiter on this specific function, and see how it works. And if you're not able to do that, please let me know in the comment section. I will do it for you. So we are good with this, everything is done. Finally we need this consumer, right? So I will say, okay, get message consumer, I'll say consumer, and it is service, right? Yes, get message consumer service. We have publisher service and consumer service as well. So I will say, okay, return this message consumer service, and here we need connection, right? RabbitMQ connection. So that I will create a RabbitMQ connection variable. So I will say RabbitMQ conf, and we are going to again use the configuration object over, not object but the package which we have created before. So I will say config dot get new RabbitMQ connection. That's what we made over there, and then we will just return the address of this message consumer. So I will say, okay, that's fine, and you need configuration, so I'm giving you this configuration. Cool. So we are done with this. I will save this code, and what error? Okay, we don't have any error over here. We should be able to use this. We are done with this all, and then finally what we are going to do, we are going to create all those functionalities, implement all those functionality on processor. So how can we do that? We know that we have process function over there, so we need to implement that process function. So I will say, okay, func. So that's the beauty of actual interface. I will show you how. So you can see here we have not implemented that process message over here, but then we are able to use that here in the consumer. How? That should not be possible. But there comes the concept of interface, and this is how it works. It will make your code highly flexible, and you should be able to achieve polymorphism. So without talking much, let's implement this interface. So I'll say func and then message processor, and this time okay, we need to give the variable name here as well. So I will say okay, message processor, and this message processor now will have this process message function. So I'll just copy paste it here, and error is there. Okay, that's fine. So I will say okay, I have the message, actual message here, right? Not actual message, basically I have the access of message, of course message. And why we are making this interface, we know that we don't need to couple this code to the specific RabbitMQ, since this is an interface, right? But then this is the implementation message processor, this is implementation as per RabbitMQ. That's why we are typecasting this to RabbitMQ. If later we are going to use Kafka or some other message broker, there we will be using this as per that functionality, right? So I will just say okay, that's fine. This message I am expecting to be AMQP, since this time I am using MQP delivery. It is going to change as per the functionality. Fine. Next I am going to say okay, variable event is nothing but the data. I will say event is going to be the data, and this time I will say interface, because the data which we have posted to the or feed it to the message queue was basically a string and interface data, right? Map of a string and interface. So next I'll say error, and in this case error is going to be error, and let's check for the error, not like this. Okay. Now next what we need to do is we need to map this message to this specific map of string and interface. That means we just need to convert this message, because we will be having message as a byte. We have published the event, and that event in that event we are basically passing the bytes, right? Array of bytes. So how can we do that? We will say okay, error equals to, and use JSON package for that, JSON, and then I will say unmarshal. That means this data will get again unmarshaled into the event object. So how can I do that? Unmarshal, fine. So now not unmarshal, it should be a small m, and then we are good. And here we will say okay, just provide the data. So data, we know that we have access of message, so data will be message.body. Cool. And then we need where we want to map this data. So we are providing the address of this event so that it will modify the actual event. Fine. And then we should check for the error as well. So I will say okay, if it is nil, then we need to use this logger, and for that I'm going to say okay, use this logger which we have created, custom implementation of the logger. So I will say use this printf function, so that we should be able to log the message in a specific way. And in this case I'm going to say failed to unmarshal, or we can say anything which we want, but this should be a specific message. So I'll say message, and then I will just log the actual message, not message but error. So for that I'm going to use v, and then just log this error. Fine. And we need to do one more thing. Let's say if that message processing is failed because of some reason, right? And that issue can be rectified later. For example, let's say this kitchen handled this order, a specific order, to this particular chef, and for the time being this chef is not available. Maybe he has gone for the washroom or somewhere else, but then this order should be reprocessed, because that order is actually correct, right? There's no error or corrupted data over there. Then how it will be reprocessed? So for that, once it will come here, if there is no available resource, we will say okay, that's fine, or there is any error. So in that case, I'm going to say okay, I won't acknowledge this message. So for that we have NSCK function, that means not acknowledge, right, on the message object. And we can say here false, but then requeue, that means requeue this message, that means put this order once more on your list. So I will say true. Fine. If the of course if the order is not created, or it is not, pizza has not been baked, then you should have that order in your list, right? So the similar thing which we did here, and we will say okay, in that case return error. Fine, that's cool. And then we have to implement couple of logger here as well. If you want, you can implement, or else you can omit this. This is completely optional, but just to debug the error, just to see what is happening over the console, we are implementing this. So I will say fmt.printf, and here we are going to say okay, processing message, or we can say processing order. So I will say processing message, right, and I will just log that message which is getting processed. So in this case, of course, we will be having the message, actual message in the event which we have unmarshaled, right? So we are good with this, and then now we need to check for certain status. And how can we do that? We will say okay, we know that we are going to check for the specific key on a map. And how can we do that? We use like this value, and okay, two value will be written from a map, and I'm going to use this map event, and I will say order status. Fine. And if it is okay, then it will come here, switch. I will switch over the value now, just to check what is the order status now, current order status. Okay, so I will make couple of case over here to check the order status, like okay, this order is just now ordered. So if it is ordered, we need to start from scratch, right? So that's what we are doing here. I will say okay, case constant, I will say constant, okay, and from where this constant will be coming. So for that, I'm going to create one more folder over here. I will say constants, right, and then inside that folder I will create a file constant, and I will say .go. So let me just make it package constant, and then I will have a constant defined over here. And how can we define that? We know that. How can we do? So let's define all those constants which we are going to use over here. So very first thing, we are going to create a queue constant. So I will say kitchen order queue, and it is going to be, let's say name is going to be kitchen, simple, right? This is again one optional thing. If you want to name it as per you can do it, of course. And then I will define a couple of order here. So I will say not order, but the order status. I will say ordered, that means just now order came, and then I will say ordered, and then I will say order accepted, and in this case I'm going to say okay, that is accepted, and we have couple of more. I will say order, and I will say preparing. Once order is accepted, of course it should go in a preparing state, right? So for that I will say preparing, and we will be updating all those status. We'll see that in action. And then I will say order, and then preparing is there, fine, we need prepared as well. So I'll say prepared, and in that case we will be having prepared, right? And what else we have? Once order is prepared, we can say order delivered, we can say delivered as well. So delivered, right? So delivered, fine. And then we will be using a couple of more constant just to send the message, and we will say okay, order prepared successfully. So So I'll say prepared successfully, right? And here we are going to say order and prepared successfully. Fine, we are good with this. And then we have a couple of more messages. I will say order delayed. Let's say because of some reason order got delayed. So we'll say we are sorry. We are sorry, your order is delayed. Your order is delayed. Alright, this is just for the demonstration. You can put, if you are making real application, you should put the specific message and you should put a very descriptive message as well. So I will say order and I will say cancelled, but the concept will always remain same, and this is how the way which we are following here. You should be able to apply these ways, apply these methodologies to create a very highly scalable application. Alright. So we regret to say your order has been cancelled. I will say we regret to say your order has been cancelled. Fine. Let me just save this and come back here, and this time I will just compare it with constant, and it will be coming from the constant package now. I will say okay, that is fine, and you need to check for if, okay, you can see all those constant over here, right? So very first thing I will say okay, ordered, I will check. If you have ordered, the status of the order is ordered. That means no one has picked up those order, or the status has not yet been changed. And then for that, this is one case, and let me just put the default case as well. So we should not forget the default. And in this case, I will just say simply logger.log and just put a simple message, no order present, no order to process. That means you are sending and something which has not to be processed by, which is not to be processed by the chef. It is something else which you are sending. So I will say no order to be processed, fine. Let me just save this, and we will define a couple of more functions, but that function will be private to this specific struct. It is not going to be exposed outside of this struct. You can say this is kind of a helper function we will be using here in this case, so that our code will be much cleaner, and we should be able to do, we should be able to write all the functionality very neat and clean. So I'll say okay, just register one function, and this time I will say message processor, of course, and I will say handle ordered. So when order is coming first time, the status will be ordered. So I have used the term handle ordered, and of course we need a data, the order data, and the data we know that it will be a map of a string interface, because we will be passing those data from here. So I will say interface now, and then of course if there's any error, I will just return that error, right? Now I will just copy this function from here and paste it over here, and one more, since we have ordered status, and then we will be having let's say preparing status, right? And then this time we are just going to implement 3 status, right? And if you want to extend it, you can take out this code and extend it further. So handle order, and then I'm going to say handle order prepared. Once the order is prepared, this needs to be it need to communicate to the client, right? The notification should be there for the client or the customer that your order has been prepared, come and pick up those order, right? So let's start implementing this functionality. So I will just say variable error, and it's error, fine. I will just put a couple of log here. I will say logger dot log, and I will say order accepted, because you just picked up those order, that means order accepted. So I will say okay, fmt dot printf, and just say order, and what is the order? So order accepted, fine, and then order is going to be the event, of course. Fine, we are good with this, and finally we will update the order status as well in the actual order object. right? So I will say, okay, event of order, not actual, but the copy of this copy which is getting paused here. So I will say order status, and this time order status is going to be constants dot order preparing, because order is now accepted, it should go in the preparing state. Fine. So I will say preparing, and here we will say response and error. Do we need this? Actually no, we don't need this. So we can, okay, we need this. So we need to publish this message to the to-do list or message queue saying that, okay, the order has been prepared. Now you need to do the next thing. Okay, you need to process it. Basically order is prepared, you need to send this pizza to add cheese or topping, something else, right? So I'll say, okay, error, not error, error has already been defined there. So I'll say error equals to, and I will use this publisher to publish the event, and this time I'm going to say, okay, use this queue which we have defined there, kitchen order queue, and then publish this event there. And how can we do that? We know that we need just event to pass in that function. So we are good with that. And finally I will say, okay, if that is the case, if error not equals to nil, right, that means error is there, and if there is any error, that needs to communicate to the client as well. That means in this case it need to communicate to the customer that there's something happened in the kitchen, or there's something happened with the pizza shop, so that your order won't be processed, or your order will get delayed or cancelled based on your requirement. So I will say, okay, logger.log, and use this printf, and this is going to be error, right, error, and we are going to show the actual error which we are getting. And this time we need to console event as well, so that we can see for the specific order this error has occurred. And for that also I'm going to say, okay, %v. Now just pass this error and then the event for which it occurred. Cool. Once we are done with that, we will have a message as well here. So I will say message, and this message has to be communicated to the client, to the user or the customer, right, saying that your order, there's something wrong with your order. So I will say string, and then the message is going to be string as well. So I will say, okay, use this key message, and I will say constant dot, and this time I will say just your order has been cancelled because of some issues. There's something which is not good in the pizza shop. That's why we are cancelling your order. And the error is, of course, if you want to be more specific, I will just give you error as well. Cool, we are done with the message. Then we need to pack this message. We need to create a byte of this message. So I will say create a byte of this message, so that we know that the message which we are going to send to the client or user or customer, that should be in a byte array of byte format, right? Then only it will go through the WebSocket communication. Or we can use JSON as well, but in this case we are using array of byte for the simplicity. So I will say, okay, that's fine. Then just marshal it, and I will say message. Cool. And then I will say variable error. And do we need this error? No, actually we don't need this error. So I will just say if mp.connection, right, if connection not equals to nil, that means we are checking if we have active WebSocket connection. That means client or the user or the customer is connected to our system, somehow connected to our system, so that we can transmit this message, we can convey this message to the specific user, specific customer, correct? So for that I will say mp.mutex, and then I will say log. Very first thing we need to do mp.mutex.log. That means I'm going to log this resource so that I can send the message. So I will say once I'm done, then I will unlock this resource, unlock this WebSocket connection so that other can use this connection. So I will say mp.mutex. There should be a function unlock as well. So I will say mutex.unlock. This is as simple as that, right? You just need to use this. So finally I will say, let's say pizza, and then I will say this pizza is nothing but the shop or the client, you can say, and then, or I will say, okay, this pizza is actually the client in this case, because the kitchen is handling. Let's go back to our application structure, and here we can see this kitchen is actually handling our messages, is handling our orders, right? And then once there's some issues, this kitchen will actually send the response here, and this is the actual interface through which client is connecting, right? So message has to be transmitted from here to here, and that's what we are going to do. So once the message is available here, then as a user, as a customer, we are in the shop and we should be able to see that message, right? So same thing we are going to do here is, okay, we'll say fine, let's access the connection. We'll see the connection is there or not. Okay, connection is of course not nil, so access this connection, and this time I am assuming the connection as to be saved as name pizza. Let's say pizza shop or something, but let's make it pizza for now. You can name it whatever you want. And of course, if pizza is not nil, that means if that client is connected, that client is there, connection is open. So I will say, okay, if it is not nil, right? So I will say, okay, that send this message then. So for that, I will just do mp dot connection, and we know that on connection we have, since this is a map, so we can take out the connection because we are storing the connection as in map. So I will say, okay, now send message. So I will just pass this message bytes over here, and finally we are going to return error if there's any error, not here, but we can return error from last here. So we'll say return error if there's any error, and if there's no error, that means this will be nil, of course. Fine. We are good with this function, and then handle order is done. We need to implement this both as well. So I will just copy this from here and paste it here, because logic is mostly going to be same, only we are going to put some delay so that we can show you that, okay, this order is going to take this much of time, and then after this much of time only this order is finally prepared or this message is handled, correct? So for that I will say, okay, order preparing we have, and then what else we have? Okay, we have order prepared, but in order prepared what we need to do is we need to update the status, that means order prepared successfully. So I will say order prepared successfully. Do we have, okay, no, first we will handle the order preparing. So in this case we are going to say order has been prepared, right? And then we'll pass the same to the publish event, but here I am going to say one thing, and what I'm going to say is just put a delay for certain duration, and it should not be a certain duration. Maybe the customer has ordered pizza, or maybe the customer has ordered 10 quantity of pizza, right? So it will take time for 10 quantity to bake the pizza, right? And if quantity is less, of course that would get processed much faster and it will be baked very easily. So time should be basically random, so that we should be able to see that in real time. And for that I'm going to create one folder over here, utils, and in this I'm going to create one file. I will say new file, and here I will say utils.go, and this I'm going to create one function over here, and that function is going to return you it will just return you a random time basically. So random is second, you can say, between a specific range. So we should be able to say some range. Okay, give me random second between 1 to 5. So it will give you that time. So I will say, okay, just write a plain function over here. I will say generate, not a small, it should be exposed. So I'll say generate random random, and I will say duration, fine, minimum, and then I will say maximum. Cool. And both is going to be of type integer. You need to say, okay, you need time between this duration, between this range actually. Okay. And here I'm going to say if min greater than max or min less than 1, that means we are going to give some error, or we are going to say, okay, panic. That means we should not use this time to create a range, to create a random time. All right. So I'll say invalid range, and then invalid range of time actually, to be more specific. And then I will use this random package, and not from crypto. You need to be careful. This should be coming from the math random dot, let's say, seed. All right. And then I will say time dot now, and basically we are going to take out the time in millisecond. For that we are going to use Unix Nano. It will give you time in millisecond. And finally I am going to say, okay, random second, and this is going to be rand, and import it from the math random package. And here I am going to say random dot intn basically, and then this expects max value. Basically I will say max minus min plus 1, fine. And then I will just add the minimum. Finally we have random second in our hand, so I will say return time dot duration, and I will say random second, fine. And then we are going to just multiply this with time dot second. This is completely logic, and using this logic you are just going to create a function, and this function will return a random time between a range of values. Let me just save this, and I will come back here in the message processor. And here what we need to do is message processor service is there, right? So we are going to put certain delay over here in preparing. Okay, here we won't be putting any delay because order is accepted. So here we will put certain delay, and then that's all. So for that what I'm going to do is, okay, just before publishing I will say just sleep for certain duration. So for that I will say utils dot we have created a function, right? So I will say utils dot generate random duration, and I will say use between 1 to 6 second, okay, random time, sleep for random, so that it will give you a real visual effect that, okay, this much of time is getting this much of time is being taken to bake pizza, or process the message, or handle the message, handle the order. So we are good with that. And then once the order is prepared, we are just going to say, okay, order prepared successfully, right? So we will say, okay, order has been prepared successfully, and I just need to change the status to order prepared successfully, fine. Now in case of order prepared successfully, we don't need to do anything, we'll just return the message to the client. And how can we do that? For that we need this much of functionality. I'll just copy paste here. We don't need to publish this to client now, so I'll just copy paste here. And then this should not be order accepted, this should be ordered, and it should be prepared successfully. All right. And we can put order number to be more specific. We don't need whole order over there to console. So we can say order number over here, and we are good with this. Order prepared successfully. We are changing the status, and then the same message we are sending to the shop, pizza shop. That means on the UI, so that user, client or customer should be able to see that on a kiosk machine or a screen that, okay, this order is having issues, or there should be someone who will be communicating to the customer or the client, right? So now we have all these messages and all those concepts. We are going to use the same, but in this case we won't be having error. In this case we will be having order, and then we can say order is going to be your event, of course. Okay, this time this is not going to be string but the interface. Fine. And of course you have changed the order status over here. Then message, what message? Okay, this should be a status actually, so I will say what? Okay, we don't need to change the status because the order status has been changed here itself, order prepared. So maybe if you want, you can change this status to delivered. So the client will come to know, okay, the order has been successfully processed, baked, pizza has been successfully baked, and it is delivered to the client. So that's fine. I will say order delivered, and here we need to say, okay, order, here actually message should be there, order prepared successfully, order prepared successfully. We are good with this. Just save this function, and then we don't need any delay over here, we just need one delay over here. That's completely fine. We are good with this all function. Now let's use this function here. So I need two more cases over here, so I will say okay, fine, but this should not be order. In this case it should be order preparing and then order prepared. So I'll say order prepared. Fine. So we are good with all these things, but then we need to acknowledge for the message as well, because if that is successful, we have successfully processed the order, we have successfully baked the pizza, we need to say, okay, we are done with this, it's successful, it's ready to deliver, right? That's what we need to say, so that this message which has been processed by the chef should get deleted from this message queue, right? Because next time the same message should not be processed. Alright, so for that we are going to acknowledge for this message. And how can we do that? Let's see. So very first thing, it is going to be ordered and preparing, then prepared, right? So I will say okay, just use this function mp.handle order ordered and just pass this event. It is expecting to have this event actual data, and here itself, here also we are going to use mp.handle order. In this case we are going to use preparing, and it is also expecting the same thing, and next one is also expecting the same thing, but only the method difference is there. So I will say handle order prepared, and this is also expecting the same thing, right? This way we are not blocking our kitchen, we are not blocking our consumer or go routines to wait for a specific message to handle. Instead what it will do is it will start taking all those orders which is coming and start assigning all those orders to a specific go routines or a specific chef. They will independently bake those pizzas or handle or process those orders. Cool. And this is how our application is more scalable. Our application is more flexible and robust, right? There's no any line of code, there's no any functionality which is tightly coupled to each other. You can see here RabbitMQ is playing independently, this chef is playing independently, no one is tightly coupled to no one is basically coupled, not tightly, but the coupled itself is not happening, coupling is itself not happening. This routine, this chef is not coupled to anything. It is just waiting for the message came, it start doing its work. That's it. And here also everything happening in the same way, right? Now you can scale this application as much as you want. All right. So of course that depends on the resources and all, but the code wise it's highly scalable. And then we are done with this. Finally, next what we are going to say is, okay, I'm done with this, and I will say okay, finally acknowledge the message. So I will say if there's no error, I will say acknowledge. For that we have ACK function, and I will say false. That means I'm not going to acknowledge multiple message, I'm just going to acknowledge a single message. And if there's no error, this should be returning nil. But before that, here we need to check for the error as well, because this case functionality may return some error, and for that we need to check. So I will say okay, error not equals to nil, and in that case what will happen? In that case logger we'll just put logger first and log, and this time I will say fmt dot sprint. I want a specific message, so I will say error processing message, or you can say error processing order, right? So I will just log the actual order over there, and you can see here I'm using error. So we are good with this, and if of course there is any error, we need to just nack means not acknowledge. All right, that means this order should be handled once more. This order is going to be requeue. It's going to be again inserted back into the queue so that it can be processed later, right? So we are good with this, and then return the error finally if there's any error. Of course, we are done with message processor. We are done with all of the functionality that is related to consuming and publishing the message. And finally, we need an order handler. Okay, of course we have order handler over here, so we just need to get, I will say order handler because this need there should be a publisher over here which will, once order is arrived on a shop, it should change the status to, you can say, accepted, or of course it should be ordered in the very initial case, right? So now we need a publisher access over here, so I will say okay, use this service dot, and service dot, it should be I message publisher, right? That's what we created. So I will say I message, instead of using the concrete implementation functionality, we will use the interface. So I'll say message publisher, and then I need one more thing over here, response service, so that we can send response, or just we don't need that for now, let it be. So what else we can do here? I will say okay func, and then I will just create a handler, order handler, and I will say create order. Okay, and this, since this is going to be handler, we know that we are going to use gin, and we have that package installed at the very beginning. So I will say give me a pointer of this gin, and this gin have context. So this function should have this context, and then it will work in the expected way as a handler. Basically, we should be able to assign this function to the routes where request will be coming. So I will say okay, string of, let's say data will be coming as a interface. I'm not going to use type checking or something for the simplicity of this application. If you want, you can implement that, but then again I will say the same thing, concept remains same. The procedure which we are following here, the methodology which we are following here will be highly scalable if you are following this process. So I will say context dot should bind JSON. This context will have a function should bind, and it should be JSON, I believe, JSON, yeah, and then I will pass this payload so that the data which is coming into the request body will get mapped to this payload. If you want to create a DTO, you can create a DTO, and then the data will map to those DTO. Fine, this is just to take out the data from the request, or you can say request payload or the body, right? And then finally I will say error, if error not equals to nil, in that case we know that error is there, so we will say okay, return the error from here. And how can we do that? So for that, again we are going to use context object, and this time we will use the JSON. Why it is giving error over here? Let's see. Okay, could not import, so let's just click on fix, and it should be able to fix these issues. Let's see if that works. So meanwhile I will just start writing this, and this JSON is actually, I think, expecting the code, and I will say okay, there's some error with the payload, so code will be 400. That means of course bad request. And then if I want to return a certain message, so I should be able to do that as well. I will say bad request, not like this, bad request. and I just want to return a status code as well. So I will say status code, and this time status code is going to be 400, so that client may handle it in a different way, handle it in a specific way. But if that is not the case, we don't have any error, then we should be able to publish this message to the RabbitMQ. And how can we do that? So I will say just change this order status to ordered. Whatever is coming from client, don't trust on those data, because that data can be, let's say someone modified the data and they made the order status as accepted. So by default, how can it be accepted? It can't be accepted, right? So I will say constants, and then I will say ordered, and it is not getting imported because of this. You can see here something is running over there, and it should fetch this gin context. So now I just need to do constants dot ordered. Let's say ordered, fine. And we are going to import that package over here. How can we do that? Let me just do it now. So instead of service, I know that constant is inside constant package. So use this constant package and do it. Now we are done with this fetching out order from the request payload, and we just want to publish it to publisher. I need to name it properly, message publisher. That is good way of defining a name or variable. And then I will say message publisher, and it is going to be, let's say, okay, we need to publish the message, right? Publish the event. So it has one functionality, which is of course publish event, and then that expects a queue. So I am going to use same queue, Control C, and I will do Control V and dot, and we should have that constant over here, and constant is of course kitchen, and it should be order, and the queue, I believe this is the key. So next we need to pass this payload, we need to publish this event, so we need to pass this payload here as a second parameter. We are done with this since it is published. Now we just want to return the message to the client saying that okay, this is successful, order has been accepted, or order has been, your request is basically successful, you are posting order, that's successful, we have received those order requests. So I will say okay, if that is the case, then use this ctx.json once more, and let me just remove this gin so that we can install it manually. It should not be, it should be basically working in your case. In my case, my Visual Studio Code is not working properly. That's why I am seeing this issue. Actually, this is related to slow processing. And then we are good with this. I will just use this message 200, and then we need to pass certain message over there. So I will say gin.h, and not like this, we should not give a space over here. So I will say okay, that's fine, that's cool. And then you should have a certain data back to you. So I will say okay, that's fine, you just take this data. So I will say data, and I will say the same payload, alright, which I have accepted from you, and then status code will also be there. So I will put a status code, and in this case I am going to say okay, status code is going to be 200, right? And what else we have? Order accepted, that's it we have, right? And if we want to put message also, we can put message as well here. So I will say message, and then it is going to be order accepted successfully. Let me just save it. We are done with this, and this handler is actually expecting this publisher, right? So it is expecting message publisher. So I will say message publisher, and then I will say service dot, of course we are going to use a interface, not the actual implementation. So message publisher, right? Now this message publisher will actually be receiving here, will get received here, and then we'll be creating order handler, right? And then we will assign this message publisher over there. So I will say message and publisher, right? And we will say, okay, message publisher is there, so message publisher, which we are getting here in the arguments, right? So let me just save this, and we are done with this function. Finally, what we need to do is we need to create one more handler where our WebSocket connection will come. So I will say WebSocket, and this is going to be handler, WebSocket handler.go, right? And what we can do over here is we can say, okay, just first thing first, package we need to define, package name, and of course this is going to be handler. And we will say, okay, let's create not handler, let's create a type over there, and this time I'm going to use interface. Why? Because we later point of time, if we want to change this gorilla to something else, we should be able to do that. So I will say WebSocket handler, and then I'm basically making a contract. If someone agree on that contract, then I will say, okay, you just need to implement this contract, then you can use my functionalities, right? So anyone who has functionality of handling connection, or I can say handle connection, and then it will have a context. I will say context, and this is going to be gin context. So I will say gin dot context, fine, and it will have a, remember we have used this connection map over there in the consumer, right? So we have not consumer but in the processor, so we need to have those connection stored here. So I will say, okay, get connection map. So if you are a WebSocket connection handler, you should have these two functionality, and if you are adhere to this functionality, then we are good to go. You can use my function. So I will say service dot iWebSocket connection. It will store a WebSocket connection, and then of course on WebSocket connection we have couple of behavior, that is couple of method present over there. So we are good with this, and next what we need to do here is we need to say, okay, type is there, WebSocket, and I will say that's fine, not small WebSocket, it should be WebSocket handler, WebSocket not connection but WebSocket handler. So I will say WebSocket handler, fine, and it is going to be a struct. Now this is going to be the implementation. So I'll say message publisher, right? No, but why do we need message publisher here? We don't need that, because we are just going to send the message from this WebSocket connection. We are not going to accept any message, right? So we don't need message publisher here. So we will just remove it from here, and but we need upgrader. Upgrader means, now here is the concept of WebSocket. When you are going to handshake with the WebSocket connection, that means you are going to open a communication with the WebSocket, with the server using WebSocket. We know that WebSocket is a two-way communication, right? REST API is nothing but REST API is basically you request for something, you will get response, and then the communication got closed, channel got closed. That is also called a short-lived communication, short-lived channel or something, right? You requested, you get back the data, that's it, done. Again you will request, again you will get the data, done. All right. But in WebSocket, once you made the connection, it will be alive. That means from either side, you will be able to send the data. That means server will be able to send you the data, and you should also send back the data to the server at any time without asking for anything, right? So when you request for a WebSocket connection to a specific server, server will just, you are requesting using a simple REST, okay, simple HTTP request, all right. But then server will, if server has WebSocket functionality, server will convert that HTTP connection to WebSocket connection. Okay, so that's what we are going to do here. So upgrader is nothing, it will upgrade the request, HTTP request to the WebSocket connection. Cool. So for that we need upgrader, and this upgrader is of course going to be of type WebSocket and upgrader. So upgrader, I will say upgrader. Fine. Yeah. Now next what we need here is we need connection. Of course we need to store the map of string as basically we need to store the connection, WebSocket connection in a map. So for that we need a map of connection. So I will say map of connection, and then this need to be synchronized. We know that why we are doing that. So I will use sync package for that to make it synchronized, and for now I am going to use mutex. That means we are going to put restriction on the resource. We are going to say, okay, if multiple resource, multiple go routines or multiple functions parallelly want to access me, I won't give you that access. Okay. Once I am done with this, once I will free this resource, then only you can access this resource, and the same will apply on me as well, right? So for that we are going to use mutex, but then just implement this server WebSocket handler, of course. So I will say WebSocket handler, and then this should have a handle connection function. So I will just implement that function over here, and we are good. Now we need a connection. We'll be having error, just make it fast, and then we can say, okay, we have not H in this case, we have H in this case, and we will say upgrader, use this upgrader whenever request comes on this handler, HTTP request will come, GET request will come on this handler, just upgrade that request to WebSocket. So I will say h dot upgrader dot upgrade, right? We have this function on WebSocket, Gorilla WebSocket, the package which we are using, right? So I will say c dot write, not c, actually this should be context. Now it wants two things, writer, response writer, and the request, right? And the header, we don't need to say any header for now, because we are not going to make it secure, we are not going to focus on security as of now, but security should be there of course in the application, but not for this tutorial. So I'm going to say, okay, context is having writer, so I will use the gin context writer, and I will pass context dot request as well. Now next is going to be nil, of course, no header. We have finally converted that HTTP request into a WebSocket connection. We have the access of connection now, so we will just check for error. If there is any error, I will say if error not equals to nil, then just logger, use that logger to log the error. There's something wrong. So I will say, okay, format this message, I will say printf, and then I will say failed to upgrade. There's some issue happened or some error occurred to convert those HTTP connection back to WebSocket. So I will say failed to upgrade connection. Fine. But this package should be there, so we need to import this FMT package. This is Golang standard package. And then if that is the case, we just need to return it from here. We don't need to go further. So finally, we will say, okay, there's no error. So this connection should be actually closed, right? Once you are done with WebSocket communication, at certain point of time, when this function execution has been done, your connection should get closed. You cannot open a connection indefinitely, right? Now by default what I will say is, okay, using this connection I am going to send certain message. Whenever a new connection will come, they will connect with our pizza shop, right? They will connect our pizza server, will say some default message, and for that I am going to say, okay, just use this connection to write a message. I will say write message, and this case I'm going to say okay, message type is going to be again WebSocket constant and then text message. Fine. And this is going to be type of byte array, but then we can pass the string over here. I will say started taking order. So whenever you will open the pizza shop, right, your application will start and then it will say to the user interface that it started accepting the pizza. You might have see that in a pizza shop there's a screen and the screen is showing open or closed, right? So when they open this, they are showing like, okay, the shop is accepting the order. So that's what we are saying here, started taking order. All right, we are good till here, and then we will say connection equals to, and this time I'm going to say service dot, I will say new WebSocket connection. All right, and we will pass this connection. All right, and why we are creating this connection? Because to store this connection in a map so that we can reuse it wherever we want in our application. So now I will say okay, h dot okay, we don't have that function, so let's create that function. So I will say okay, func, and I will say add one function on this handler. So I will say handler, WebSocket handler we can say, or just say handler, and then this is of course WebSocket handler. And this, why we are creating this function? This function we are creating to, you know, it will it is just a helper function. Using this function we can assign the present connection to this specific map. We can store the present connection to this specific map. All right, let's say 1000 of user is getting connected to this server. We are going to store all those 1000 user connection to this map so that we can use that and send the specific message to the specific user or customer. Correct? So I will say add connection. This method is going to be private, so I'm starting it with a small letter, and I will say client ID will be there, which is going to be unique for each of the connection. And I will say, I'm just assuming that I will say connection, and this time it is going to be service dot IE WebSocket connection, that is interface WebSocket connection. Cool. Now here, whenever someone is going to use this, I will say just lock it first, mutex dot lock. Okay, and then once your functionality is done, then release that resource, release the lock on that resource so that others can use that. All right, so that's what we are doing here with just 2 lines of code. That's the beauty of Golang. So now here I will say okay, h dot connection, and then assign this connection using this client ID, which will act as a key over here. Not client ID, we are already accepting this client ID in this function, so I will say just client ID, right? And then it will store the connection. We are good with this function. Now we need one more function over here through which we can get the connection map, right? So we'll say okay, register one more function on this WebSocket handler, and this time it is going to be connection map, get connection map, right? And then here I'm going to say okay, this will return you pointer of map of string and then WebSocket connection, and that is going to be type of service dot IE WebSocket connection. Fine. This is simply going to return the connection which you are saving above. So return h dot connection, that's it. So we are done with these 2 utilities method. So here what I will say, okay, just add this connection to the specific map. I will say connection. But then what is the issue over there? Okay, first parameter is our client ID, so we need to provide client ID. Just for demonstration purpose, we assumed I am going to use only a single since this is going to be a single shop, right, pizza shop. So this shop belongs to me, and then I am going to put client ID as pizza, because I know as of now this application is not in the production. I am just using this application, so in my shop only I'm going to use this. So that's why I'm going to put this as a pizza hard coded over here. It can be modified, it can be taken from client, those who want to connect through the server. All right, we are done with adding the connection. Next, what we need to do? Next, we need to listen for the, we need to keep this connection alive, and if there's any message coming from this connection, we should be able to iterate over the message like we did in the consumer service, right? So here we are going to say, okay, for loop we are going to use, and it will just keep listening to the specific WebSocket connection messages. And here we will say, okay, event, but in this case there won't be any event, because from the client I'm not expecting any data to come here. So we can just leave this, we don't need this anymore here. If there's any message coming from the client, we are good, or else let it be, because we don't need that message here. So let this for loop be as it is. I will say just logger.log. If there will be something coming from the client, we should be able to see that as well, right? So for that I will just say no message. Let's say no message is coming from client. Fine, we are good with this now. Let me just save this. And finally we need to export this WebSocket handler so that we can create a route for this. So I will say get new WebSocket handler, fine, and this is expecting a message publisher. So I will say message publisher, not actual implementation, it should be message publisher, right? So I will say message MP message publisher, and then it will return you WebSocket, not WebSocket handler, but it will return you WebSocket handler, fine. And then here, from here we should be able to, okay, first make the connection, so that by default, if we won't make this connection, by default that connection will be nil, right? And if it is nil, means we won't be able to add the connection into a specific map, because map is nil. You need to initialize the map first. So for that I'm going to say, okay, let's initialize this whenever you are going to use this socket handler. So for that we need a make function. Make function is present on the Golang, and it's a Golang function basically. I will say, okay, just make this, and I will say service dot WebSocket connection. Cool, we are good with this. Now finally we just need to return this. So for that I'm going to say, okay, and WebSocket handler, but this is expecting a message publisher and upgrader as well as connection. So very first thing, let's assign the connection, because we created this connection above. And next, what it needs a publisher. So I will say message, where is the message publisher actually? So message publisher, okay, we don't need message publisher, we decided that before, right? So there's no need of message publisher, so we can just omit this from here, we don't need that. And we just need a upgrader, right? So now upgrader is specific to a WebSocket, so we can say, okay, directly we can use this here itself. So I'll say use this upgrader, but then this upgrader needs something. So I have one check origin function over there, and we just want to say, okay, return true, so that it won't check for the WebSocket connection to know you on the same origin from where the request is coming and from where the server is running, right? It should not be on the it should not be, but it is not mandatory to be on the same origin. All right, so I will say return true, and we are good. So why it's giving error? Okay, let's import this HTTP request over here. Fine, we are good with this now. Let's just save this. We are done with WebSocket handler. And what's the error in order handler? Okay, we missed comma over here and here as well, and here as well. So now what is the issue? We need to use gin. So just import the gin package now and then save this once more. Okay, we are done with this. Finally, what we are going to do is we are going to create a folder, and this time we are going to say it as a route, so that we should be able to access the API using the routes, right? And then for routes, what I will be doing is I need 3 different files, 2 files for this handler, 2 different handler, and then 1 file is going to be the main router file. So let's see that how we can do that. So I will say WebSocket routes, and this is the way you can separate all those logic and the routes as well. And this is basically highly modular code, and you should be able to modify it as quickly as possible. So I will say just make this function. I will say package routes, fine, and then I will create a function register WebSocket routes, fine. But then this WebSocket route needs router, and from where we need this router, we are going to import it from gin package. So I will say gin dot, and I need a router group. So if you are not sure about what is this router group and what is this gin, you can go back to my previous videos on full stack, and you should be able to understand it very easily. I have published those videos in very details. And then here what we need is for WebSocket we need a socket handler as well, right? So we will say that's fine, get me a WebSocket handler. So I will say WebSocket handler. And why we need that? Because we are going to create all this on a single file and then inject that from there, so that we should not be able to come onto the specific file and change that. Instead, from the very initial, we'll change that and it will change for all. So here I am going to say this handler is going to be a handler, and it should be WebSocket handler now. So let's see that if we are getting the suggestion. We are not getting. We should go back here, and then I will say WebSocket handler, copy this and paste it here. Fine, we are good with this. So now we have this functionality ready. I will say simply router. So any request, any GET request which is coming on this route / it should be handled by this WebSocket handler dot handle connection method, right? That's what we are doing. But then what is the issue over here? So it is saying cannot use WebSocket handler dot handle connection. And why is that so? As gin handler function in argument router dot get, that's completely fine. It is expecting a function as a handle function. Then what can be the issue? Handle connection. So let's go back in WebSocket handler and see what is the exact issue over there. So we have this handle connection, we have this gin context, and this is showing some error. Handle connection passes by load. That's completely fine. We don't have issue with that. So I will say no required module. There's some issue with the Go module, and let me just save this, see if that works. This is fine. We have that gin package over there in Go module as a dependency. Then it should be working as per expectation. Now let's go back in WebSocket handler and see if there's an issue. No, we don't have any issue, and this should be working in the expected way. Then why it is not working? So handle connection, that's fine. And what we are returning from here, WebSocket handler, right? And then if we will have access to this WebSocket handler, So on router we should be able to call that, and but here we are not able to do that. So let's say I will just use WebSocket handler, then are we able to use this? No, still not. And why is that so? So let me just fix this issue, and if you guys are able to fix this, let me know in the comment section, and I will be back in a few seconds. Okay, I found out the issue. Issue is actually related to here, the functionality which we have defined over here. So actually this should be a pointer, not the value. So it should be pointing to the address of gin context. Now let me just save this function and go back to routes, and it should be working in the expected way. So we can see here it is working expected way, but we don't need the implementation here. We need WebSocket handler, and we are good to go. Let me just save this file, and now we are done with setting up this register route. We will create one more file over here, main, that is going to be main file routes.go, and this time I am going to say okay, that's fine. So I will just create a package first thing first. I'll say routes, and then this route should have a function func, and it will say register route, and this is the main route. Basically it will add all those routes which is present inside this routes folder, and finally we will be saving this route, registering this route on the application. We'll see how we can do that. So for now we are going to say okay, register routes, and this need gin function, not function but the gin engine, that is of course the application gin.engine. So I will say gin.engine, and then I need couple of more things. One is message publisher, and who needs message publisher? Order handler need message publisher, right? So let's fix that first. Okay, for that we need to accept this message publisher first. So I'll say message publisher, and I will say service.iMessage publisher. Why we are doing this? Because we know that all those route is going to be registered here first, and then if that route is expecting something, right, then we should be able to inject that from here. And finally this message publisher we should be able to inject from our main function to this register route. That's the concept which we are doing here. That's the dependency injection basically. So here I will say okay, message publisher is there. Then do we need WebSocket handler? Yes, of course we need a WebSocket handler as well. So I will say WebSocket handler, and then it should also be there. And for that we need to say service.iMessage, not service, it should be coming from handler. So I will say handler.iMessage, not message, WebSocket handler, and iMessage. I will just go back here in the WebSocket handler. I will just copy this and paste it there instead of waiting for so long. So now we are done with all those requirements. We will say okay, use this, create a router object, fine, and just group all these APIs and group this based on the empty path. If you want to put a certain let's say API in front of this, you can put that, but for now I'm just making it simple, straightforward. And I will say router dot, what else we need over here? Do we need something? No, we don't need. So I will simply say okay, let's make a route. We have created route over there, right? So I will say WebSocket routes, and then this WebSocket routes is actually router dot. First we need to group basically base path for the WebSocket route. So I will say WS, okay, and then we are going to give this object notation here, and here we are going to call this function. So this group is nothing but, you can see here it is a router group function, and then it's expecting something like this. So I will say okay, register routes, not register routes, it should be register WebSocket routes, and it is of course expecting the router. So we will just pass router, and what else it's expecting? It's expecting a WebSocket handler as well. We are done with passing the required details here. This time router should not be there, but the WebSocket routes. Alright, we are good with this. Now let's handle this order handler. What is the exact issue over there? So we are done with this, and get order handler should return actually something. So we need to say that, okay, get me order handler. So I will say get order handler. We are good. Now let's create a route for order handler as well. So I will say order handler, or not order handler, but order, this time it's going to be order routes. So we are marching toward end of the logic of this application, and then everything will combine at single places, align all those items, and it should be working in the expected way. So let me just copy this code from here. We need such similar kind of function over there as well. So first thing first, you just define the package, and instead of register WebSocket routes, we have created order routes, right? So this function should be specific to order. So I will say register order routes. So register order routes, and then router is of course going to be imported here, gin.router group. And then here, do we need this WebSocket handler? If we don't need, we can omit this. Here we need the access of publisher only. So we can say, okay, give me access of publisher only, not the WebSocket handler. So I will say message publisher, and then we know that that message publisher resides on service package. So I will say, okay, but we are going to use an interface, not the actual implementation. That should always be in mind. We are good with this. We are okay, WebSocket handler we don't need here. Instead we need order handler, right? So we can couple this order handler here, since that order handler is not going to be used somewhere. So we can say, okay, very first thing we need order handler. So I will say order handler, and then I will say handler dot get order handler. Let me go back here and copy paste instead of waiting for so long. So I'll say get order handler, but this need a message publisher, and we know that we have the access of message publisher. So I'll just paste this function, okay, and then pass this message publisher, right? We have achieved dependency injection as well. Now this should handle actually order creation. So I will say oh.create order, fine, and the route name I'm going to put as a create. Let's go back to main routes. We have a WebSocket route over here, but we need order route as well. So we can say, okay, create a order route as well. I will say or order routes, and this time it is going to be orders, fine. And the function, of course, we are going to use order route, register order route, which we have defined just now on the order routes file. And then this is not expecting a WebSocket handler, this is expecting a message publisher. So provide the message publisher here, and the route should be order route, not the WebSocket route. Let me just save this, and we are good to go. We have set up everything over here which we are going to use, and I don't think anything is left over here. So finally we will create a main function, right? So for that main function, we know that it should exist on the root folder of the server. I will say main.go, fine, and this is going to be the main package, so it should be named as main. And what else we need? We just need a function, main function, that will bootstrap our application, Go application. So I will say I need access of application. So I will say, okay, use this gin.default. So this will give you access of application, gin application. And then I will say app dot use. If there's any issue, if there's any error occurred, so you don't need to crash, you need to restart. So I will say gin.recovery, fine. Now next I am going to say, okay, we need one more thing over here, and that is going to be course, because we need to say it explicitly that allow this specific origin, right? How can we do that? So for that we are going to create one folder and I will say it as a middleware. Fine. And I will say new file. This time this file is going to be what should be the name of the file? So let's make it middleware, simple middleware. We'll say middleware and .go, right? So here we need to allow certain routes on this specific server, otherwise the route will get blocked due to cross origin policy. So I will say okay, middleware is going to be package. So now create a function, middleware function, and we know that how can we create that. And if you guys are not aware of that, please do watch my full stack video, and I've explained all those things in detail in that video. So I will say course middleware, and this should have a method signature of gin.context, and if that is the method signature, that means it can be a handler function, it can be a middleware function as well. So here I am just going to put couple of things. I will say context.writer and .header. I will say okay, just set couple of header so that Golang will know okay, you need to allow this a specific request. So I will say access control origin, control allow, and not capital L, it should be small allow, and then origin. And next thing you need to give the the origin which you are going to allow. So I will say the request will be coming from localhost, and why? Because I'm just going to create a client for this application as well. So I will say, let's say client will be running on 8100 by default. You can use any port of your choice, but then that port, your client should be on that port, your client application should be running on that port. So I'll just copy paste this, and here I will say access control allow credential. So I will say credentials, and I'm going to make it true. All right. And what else we need? So I will say access control allow headers. So headers should also be allowed. I'll say headers, fine. And in this case, I'm going to say okay, allow a couple of headers, and for that I will say authorization, allow this header. And if you want to block some header, you can omit it from here. So authorization, you can put content type, right? You can put accept as well. So now finally we will having one more over here, and we will say method, not method but methods, and this time I'm going to say use get as well as post. Fine. Since we will be for WebSocket communication, we will be using the get method, right? And for order requesting, we are going to use post. So we are good with this, and we need to do one more thing. We need to just check for one thing. I will say okay, context.request.method, if the method is options, okay, because every time client will trigger a options request, okay, to check which all methods is allowed. And for in that case I will say okay, just about the connection, about this request with the status 204. All right. And then finally we will return, and if that is not the case, then return, then proceed to the controller. So I will say next, ctx.next, that means you will proceed to the next middleware function or next controller. I will just save this and use this function in our main application. I will say app.use. Okay, this is the way we are registering any middleware function to Gin application. So I will say course, not like this. I will say use this middleware dot course. What was the method name? So go back in middleware and copy paste it here. Course middleware. I will come back in main file, and then I will say course middleware, that we are good with that, right? So why we are getting this error? Is used as a value. It should not be used as a value. Then what is the issue? So let's debug that. Go back in middleware, and we can see over there, okay, this all are good. We have this function, and then we are just accepting the Jing context. That is actually good, but then there's an issue. There's some issue. Abort with the status, that is also good. And here, if we'll come here in the main Go, why it is giving issue? So okay, we should not call this here. Instead, we should pass this function reference or function as a value, right? So I will say, okay, app, next we need to use app.get just to see if our server is running or not. So I'll define a path, define an API with ping, and I will say, okay, use this func. And this function will have, of course, context and then Jin context. Cool. Now using this, I will just say, okay, ctx.json, simply send this to the client who is requesting and say that, yes, you are alive if you are alive. Right, 200, and then I will say jin.h, and finally we will be passing message. Let's say I will say server, or I can say pizza shop is open. Right, if our application is running, that means I should be able to connect through WebSocket. So I will say pizza shop is open. That's cool. So next I will say status code, and this status code is going to be 200, of course, because this message is every time going to be successful. Correct? We are good with this. Now align all those things which we have created. So first create a message publisher. Not publisher, okay, let's create a message publisher. I will say message publisher, and we know that we can use service for that, so I will say message publisher. Get message, and it is not giving me suggestion. Actually, this VS Code is running too slow for me, and in your case it should be working too fast. And for get publisher, I will just go here and copy this function name, because I am expecting to call this function itself. So I will say, okay, use this function, and it will give you the publisher, and then you need a message consumer. I need a consumer as well. So I will say message, and why we are doing this actually here, because this publisher should get injected to routes, and through routes it will get injected to the controller, not controller but the handler. Correct? And then it should be injected to whichever file we want. So that's why we are accumulating all those behavior functionalities at one place, and then we will pass accordingly who is expecting what. Okay, so I will say in this case, okay, service dot, okay, this time it is going to be get message consumer service. Right, we have publisher, we have consumer. Now we need a handler. So I will say WebSocket, and I will say handler, not like this, handler, right? And this time I will say handler dot get WebSocket handler. Cool. But then I need one more thing. I need message processor as well. So I will say message processor. So message processor, because when you are opening a pizza shop, right? So you need to have all those chefs at places so that they can make those pizzas, right? For that we need a chef. So I will say message processor, and this time I'm going to say, okay, get me message processor. How can we get that? I will say get processor service, but this time this get message processor service is expecting access to publisher. So we are going to pass this message publisher, and then it need to have a connection as well, so that using those connection it can communicate to the client. So from where we can get the connection? So we know that we have that on, where we have that? We have that on WebSocket handler. So we can use the get connection map which we created, right? So now we have created this message processor as well. Finally, we just need to launch a Go routine, and that will register a consumer, right? Basically there should be a kitchen, there is a kitchen which will get registered on this pizza shop, and that will actively look for the new order, that will accept a new order for processing. So I will say okay, launch a go routine immediately, and then I will say error, and here I'm going to say message consumer dot consume events and process it, right? And we know that we need to pass a queue name for that, so I will say constant dot kitchen. What is the name of queue name? So kitchen, and I will say order queue, fine. And we need a processor as well, so we created processor just above, so I will pass the processor as well over there to the kitchen to consume the event, to consume the message, or to consume the message order, right? Once kitchen is registered there, kitchen is there available, so I will say okay, if there's any error, let's check for the error as well. So if error not equals to nil, in that case I will say okay, log some message because there's some error occurred, right? So this time I'm going to say okay, so use printf, and this printf is actually going to say okay, failed to consume, and I will say events, and which event it is failed to consume, I will just pass that event itself. So I will say %v, and then I will use error. Okay, now we need to import this package fmt to remove this error which we are seeing over there. We are good with registering the consumer should be only one, so we are registering it once, and then we need to register the route as well. So how can we register routes? So we have routes created above or not? We have routes created or not? No, we don't have routes created. So okay, I will say okay, import that routes from here which we have created, and I will say register routes dot, and use this function main routes function to register. I will say register routes, but then it is expecting a gin. So gin engine is nothing but an app which we have created, and then we need to pass message publisher as well as message handler. So I will say okay, I'm going to give you message publisher as well as message handler, no, WebSocket handler. All right, we have provided all those data, all those functionality, injected all those functionality into one another where it is expected. Fine. Finally, we will have a port of this application where it can run. So I will say okay, config dot get it from env. So I will say config dot get. So let's go back in config, and in your case it should be showing suggestions. So I will go back here and I'll just copy paste this. All right, and then I need a port. Fine. If that is the case, I will say okay, logger dot log, and I will say, let's say structured message I want to show, I will say, or formatted message, I will say okay, WebSocket, or we can say pizza shop started successfully on port is nothing where your pizza shop exists. You can assume that as a address where your application is running, right? So if I'm going to arrive on your shop, on your pizza shop, there should be address, there should be a port where you exactly exists, right? So the same thing which we are going to convey here, and this time the port is going to be port, and this is going to be port. Fine. And finally we need to just run our application pizza shop. So for that we are going to say okay, use this function printf once more. And why we are going to use, because this is expecting a port in this format. So I will say okay, that's fine, I will give you port. Cool. Let's just save this. We are done with our backend. We are done with our server application. Okay. Now we need a client. If you want to trigger this functionality from a Postman, you should be able to do that. And if you want to trigger this functionality from the client, you should be able to do that as well. So in this tutorial, we are going to trigger this functionality from a client, and I'm just going to make a simple client using Vue.js and Ionic framework. In your case, if you want to make it using React or Angular or any other framework which you want, of course you can do that. So but the concept will always remain same, right? So what I'm going to do that, I'm just going to create one application using Vue and Ionic. And how can I do that? For that we have couple of method present on, not method but the command present on Vue Ionic, and let's see how we can do that. So for that, what I will be doing here is I will say okay, and if you don't have Vue Ionic installed in your CLI installed in your system, you need to install that first. And if you want to know how you can install, you just go and watch my previous videos in the playlist in the full stack development course, and you will be finding that easily. So here what I'm going to say is okay, just use this command Ionic, and then I will say start, and this time I'm going to say client, because the folder name which is going to be created for this client is going to be client. I want to name it as client. You want to make it with a different name, you can do that. So client we have, and then finally we will be having a blank application, and the type is going to be -- type, and I need Vue. Now the thing is, if you want to create this Ionic application with React, you should be able to do that, because they are supporting React as well as Angular. That's the cool feature of this Ionic. And once you write this code, this will work throughout your basically it will work as a cross-platform application. So let me just click enter, and we should be able to see something. Okay, we are getting error because the console is not giving me access to execute that. For that, what I will do is I will just close all this terminal, and I will just use a command prompt. So for that, just open a command prompt and use a similar code over here. I will say Ionic start and the app folder name, so client, and then I will say blank -- type is going to be Vue, right? So let's click enter, and it should download, it should create the project in Ionic Vue. Fine, let's wait for some time. Once that is completed, we'll start implementing all those functionalities related to, of course it is going to be a single page only, but then we will see how we can implement that functionality in our UI, and then we should be able to see an interface. So let's wait for a couple of times. So until then it will get downloaded. It will take some time. So till that time you can wait.
Now you can see here it is now getting downloaded, and it is asking me for create a free account. You can put no, and then it will again download all those dependencies. So it's almost done. We should be able to see client folder over there. Yes, we are able to see over there, and in this case we'll just open this folder, and we can see here it is just supporting TypeScript, but then we need to basically remove the TypeScript, because for now, for the simplicity, I'm just going to use JavaScript for now, and we'll just use a single page application of Vue, nothing fancy. And if you want a full stack development course, you can go back to my previous channel and you can see the full stack videos over there. I have created a cool application, and I have defined or explained all those things which we need in a full stack development. So for now, what I will do is I'll just go back on Google, and I will search here Vue Ionic project, and for that we should have a command to remove all those dependencies, not dependencies but TypeScript dependencies. So I will just copy this from here, and you can of course search for Ionic framework, and then you will come here on the main page. Now I will go back in my application, and I will say okay, just execute this command so that TypeScript dependency will get removed. So let me just paste it over here and press enter. Now you can see here it's been removed, and for that we need to remove a couple of files from here. So I will say okay, change this file to JS file because this file is required as per Ionic framework documentation, and I will change it to JS. And if you are changing a file TS file to JS, you need to remove the TS dependency there as well. So I am just going to remove this from here. We don't need a capacitor config here because we are not going to type check for that, right? So this Cypress we don't need as of now. We are not going to write any test cases, UI test cases. But if you need that, please comment in the comment section so that I will create a separate video on that, and I will make you understand how that works. So a couple of more things which we need to remove it from here. This should be actually renamed to JS. So I'll just rename this to JS. And then we are good. Let's open this file and we can see here, okay, all are good. We don't need this TS config because this is related to TypeScript file. And then what else we have? So do we have anything over there? Yes, we have actually, and we just need to remove this test folder from here. So I will say just remove this test folder and delete it from this client. Next we need to remove this ESLint because I don't need this as of now. This is kind of, you know, it will enforce you to write good code, but we don't need that now because I need flexibility now to write a code. Of course we are going to write a good code, but we don't want to face any extra issue over there. So I will just remove this as well. ESLint ignore file, and then this file as well. So next what we are going to do is we are going to rename a couple of files here. This index file actually is referring to it's loading all those scripts from main.ts. So I will just say take it from main.js. And how can we do that? Of course we are going to rename this main file to JS file. I will just say rename to JS, that's it. And this also need to be renamed to JS, so I will say JS. And what else we have? We have a router file as well, so we need to change that to JS as well. So we are good with that all, and I believe everything should be working as per expectation. So I will just click on this home page, and then I will start doing, or I will start in feeding all those codes related to client here. But I already have that code, so I will just copy paste that code over here, and I will just link this to GitHub so that you should be able to download it. And if you want to learn this, how you are going to create this page and all, please go back in the playlist and watch my full stack development course. But for now we are just going to create this and paste this, and it should be working in the expected way. So for that, what I will do here is I will just run this application and we'll see if that works. But before that, I'm going to change this. Okay, this will route to, we don't need force type checking here, so we can remove that here as well. So I will just remove this here and save it back. Now finally we'll have all those things ready in place, and we should be able to, okay, we have this tsconfig.json, we should remove that as well because we have removed all the dependency related to TypeScript. Okay, we are good. Let's run this application. And how can we run? So for that we are going to say okay Ionic, and then I will say serve. So it should actually start the application. And then okay, it should not start the application because we are not inside the client folder. For that we need to go inside the client folder and then run that command, not Ionic, it should be Ionic and serve, that's it. So Ionic and serve. You can see application has been started on port 8100, and if we will go back in browser, we should be able to load that file, and let me show you that. 8100, you can see that page is loading, and of course the page is being rendered over here. So that is the default page which Vue.js Vue Ionic application is showing. We need to modify this page and show some cool UI over there, and we will see that in action in a few seconds. And for that, let me just copy paste that code, that client code, because we are not focusing on client, we are focusing more on the RabbitMQ, the functionality which we implemented, we learned throughout this application. So what I will do here is I will just control copy this and paste it somewhere so that I should be able to take it from there. And in this case I am going to use pastebin for that. If you guys are not aware of pastebin, you can use pastebin to transmit the code from one place to another. Not transmit, but you can provide this code to someone who should be able to open that link, and they will be able to copy that content. I will show you how it works. So I'll just create a new paste over there, and this time I created a new paste, and I will say okay, pastebin.com, and this is going to be the link of the paste which I had created before. So I will say Z and PIS capital Z. So if I'll open this, since I have already created this pastebin, you can see here I have all those code ready at places. So I will just do one thing. I will copy this from here to the bottom. Let me just copy this all and paste it in that home page. So I will just copy it from here and come back to the VS Code, and I will paste that code in our home page. And of course this home page will get replaced with the new file, new content which I have pasted over here. I will save it, and we can see here something is getting broken. And what is that exactly? So we can see here update await this dot post order, unexpected word await. Okay, so await should be only used with asynchronous function. That is the issue, I believe. So for that, what I will do here is okay, await, where's that? So of course we should be able to connect to our WebSocket application, but then we have okay, post order function is there, that is completely fine. This await dot post order, but where we are calling this await? Okay, we are calling this await here. Then this function should be asynchronous function as per JavaScript, right? Let me just save this and see if that works. Yeah, that works actually. Let's go back in UI and see if that page is actually working. Let's refresh this page and see if that works. It's loading. Then what can be the issue? Is there any issue which we are facing over there? So let's go back to code and see if something is getting breaking. Okay, there's nothing breaking, so it should be working basically. So I will just go back in. Okay, you can see here that's nice cool interface, right? Basically the purpose of this interface is you should be able to take as much as order, and then this order will go here, right? And then based on the RabbitMQ connection, this order will the order status will change, and we will see how we are going to do this, since we have created our backend application and it should work in that way, right? But then there's one issue. We have created our backend application. We need to run this application as well. We are running this UI application on our host machine. We need a dependency of RabbitMQ as well, because RabbitMQ need to be there in your system to run this application, our server application. And for that, in this tutorial I'm going to use a Docker. And if you guys are not aware of Docker, what Docker is, you don't have to worry about that. Docker is nothing but a tool, a software, a virtual environment where you can run your server application or any application which you want. Basically it will give you a very minimal version of the very minimal image of the application or software, all right, and on that you can run your own application on top of that. So if you don't know Docker, you can just follow along with this tutorial, and this is not tough, this is actually very easy. You just need to download the Docker and You just need to write couple line of code, and it will work in the expected way. So what I'm going to do here is I'm going to create one file over here in the main folder, and this time I'm going to say, okay, this file is going to be, okay, not here. Very first, I'm going to create a file in the server, and that file name is going to be dockerfile.dev. And why I'm putting dev over here, because for a specific application, you can have a Docker file related to a dev environment. You can have multiple environment over there, right? Dev, stage, UAT, or something else, right? So for that, this is the way we can manage a Docker file, multiple Docker file. All right, so I'll put docker.dev, and then here we need to write a Docker configuration. So based on this configuration, our application will run. Our application will create a container, and then on top, inside that container, our application will run. So we will see that if you're not aware of Docker, if this is new for you, forget about everything. You just following along this tutorial, you will get to know what exactly is happening. Okay, so I'll say from, and this time this is going to be a main application, Golang application. So we are going to use Golang, and we will say the latest version of the Golang. As of now, it is 1.23, and if you guys are watching this video later, you may have the new version as well. So always use the new version, which is of course going to be bug free. So I will say, okay, that's fine. So as a builder, I will say, and then you need to set some environment variable if you want to set. So I will say, okay, use this environment variable go11 module, and this is going to be on, and couple of more variable I want to introduce. So I will say CGO, and it will be enabled, and what does it exactly it will do. So if you want to understand, you just put the comment in the comment section, and I will try to create a separate video on the Docker container as well. Docker basically I will try to create a Docker tutorial for you. All right, so here I will say enabled, and then it is going to be 0, and I will say goose, and it is going to be Linux. The machine on which your application is going to run is going to be a Linux machine, and I will set the work directory as well. So default directory of your application. So I will say /app, and then I will do copy go.mode. So this go mode is basically responsible for handling all those dependencies, right? So I will just copy this go mode from here, and I will put this inside a container, go mode and go sum file as well, and put this inside a container inside /app. That is going to be your work directory, right? Once that is moved, I will say, okay, run go mode and download. That means it will download all those dependencies. Fine. And next I'm going to say copy rest of the file. Okay, this way Docker will cache basically Docker is caching all the layers. Let's say in first build you have completed this one, and in the second build if you will come, this will get cached. That means it won't be executed. Docker will take it from the cache, and next code will get executed, next line of statement will get executed. That is how Docker works. So here I'm going to say now run go build and -o. That means finally you have downloaded all those dependencies, and you just need to create the application and run this application. So not like this, okay. Now I need to put one more thing over here. Stage 2 is going to be from, not like this, should be from, and then I will use GCR. It is nothing but a minimal production image of the Golang. Okay, so I will say gcr.io, and I will say distroless, and if you want this configuration, you can search it online and you will get that easily. So there's nothing wrong with that. So but you need to understand what exactly it's doing. So I will say non-root, and still if you are not able to get it, please let me know in the comment section so that I can make a separate video on this and make you understand it in easy way. So I will say copy, and then from equals to builder. So what it will do, I will let you know. It will go inside app main app, and then main, then dot, and then what it will do is it will expose the port, expose 8661, and user is going to be non-root user. We are going to create non-root user, so we'll say non-root. And why? Because we should not allow someone to log in as a root user to the Docker container. All right, because that Docker container is of course a machine, so we should not allow that. So I will say cmd, and finally it will, using this cmd, we should be able to run this application, main application. Fine, we are good with this. We are creating a container. We are basically saying, okay, get this container from the Golang, okay, install all those dependencies, and then finally add one user as a non-root user and run this application. That's what we did here. So we are done with this Docker file. Now I want a Docker Compose file, because what Docker Compose file will actually do, Docker Compose file will basically search for all the Docker file present inside this folder, okay, root folder, and then it will build all those container at once, so that we don't need to run it one by one. So for that I'm going to say, okay, let's create one more file, and I will name it docker compose.yml. Fine. And why we are using this? We are going to use this only for even we are not going to run our application in the Docker. We are just going to define that Docker dev. If you need it, you can use that. So here I will say, okay, we need one services. So before that I will just say version. Let's say I'm going to use 3.0, and then I will say services. This is how you are writing a YAML configuration file. And then indentation matters. So I will say, okay, this service will be everything, every application or every container which will run in Docker container is said to be a service. So I will say RabbitMQ this time, and then the image name. So image name is going to be, this image should be coming from where? So I will say this image should be coming from the RabbitMQ official image. So it has the name RabbitMQ management. All right, and then we need to put the container name as well. So I will say container name is going to be Rabbit and MQ. Fine, and then we will have ports on which RabbitMQ will be running. So by default RabbitMQ is running on port, so it is running on port basically 5672, and then this way we are saying, okay, internal port is going to be 5672, and the or external port will always be should be same. So I will say, okay, 5672. Cool. Now I am going to expose one more port, and in this case I am going to say 15672 and 15672. Cool. Next, do we need an environment variable? Yes, we need an environment variable. So for that we can say environment, and I will pass couple of variable over here. So I will say rabbit, it is expecting in that format actually. So I will say RabbitMQ, and I will say default. I will say user as well over here, and this time I'm going to say the default RabbitMQ password and username is guest. Okay, so I will just copy it from here and paste it once more. I will just copy this and paste it here, and this time I'm going to say this is going to be password. Okay, if you want your application to run inside a Docker container, you can put that as a service over here like this. But if you don't want, if you want to run it here itself in the console, in the VS Code itself, you can run in that way as well. So for the simplicity, let's run this in the VS Code itself. If you want, you can of course do that. You are free to do that. So let me just close this. And one thing which we are missing from here is we are missing one thing, and of course that is environment file .env file. So let's create that file in the server root folder. I will say .env, and then this should have all those envs. And what env we are expecting over there in our application. So for that we'll say very first thing is going to be the port, and it should be at 661. All right, and what next we are expecting in our application. So we are expecting certain things about RabbitMQ. So I will say RabbitMQ and I will say host. All right, host is going to be local host because before creating this application, let's run this Docker container. Meanwhile, that Docker container will actually load. And how can we do that? So for that, you can see here I have this Docker container. I will just click on this Docker container and open this application. And when I will just run this Docker compose file, it will run the container in this, and you will be able to see that container in this Docker interface. This is just for who don't know Docker, and if you are aware of Docker, you know Docker, so you can skip this, of course, and you can proceed next to see how we are going to test our application, if that is working fine in the expected way or not. So just wait a couple of seconds or a couple of minutes so that this container is actually started, and we should be able to trigger this. Okay, meanwhile I will just say okay, let's create this file. RabbitMQ host is going to be localhost. I will create a couple of more, and in this case port is going to be port, and port is going to be 5672. On this port only we are going to connect to RabbitMQ, and then host is there, port is there, and then what else we need? We need a username as well, right? So I'll say username, and then username is of course guest. Password is also going to be the guest. So I will say password, and it is going to be guest. Now we have defined one more thing in RabbitMQ configuration. Env configuration. If you remember, we have defined default queue as well, default queue name. So I will say RabbitMQ default, and I will say queue, right? And then here I will say default underscore queue. Fine. Now we need one more thing, log, because based on the log only we are showing all those log on the console. So I will say okay, use log for now, just so that we can see all those things in our application, right? So let me just save this, and you can see here Docker is now running fine, and not running even though we have not executed those command, and script is also not executed. So let me just delete all those containers from here, and we should be able to, okay, what is this? Okay, let me just delete this as well. And so now you can see it's completely empty, and I will just run this Docker compose configuration. And how can we do that? So for that you need to just type Docker, but to make sure you should have that Docker in your system installed there. So I will say Docker compose up -d. Why we are going to use -d? Compose means this will pick up, this will actually search for compose file, docker compose, docker-compose file .yaml, and then it will search for in this specific folder where you are executing this command. Okay, and -d is nothing but it will run this command in a detached mode so that your terminal won't get blocked. Okay, so let me just click enter and see if that is working fine. Meanwhile I will just go back to UI and see, yeah, everything is fine. But here you can see now this RabbitMQ container is actually being created, and it's getting started as well. So we should be able to see that container actually. Let's see if that works. And why we are getting this much of error over here? We are getting 78,000 error. Let's go back in console and see what error exactly we are getting. Okay, this hangs actually, I believe. Let me close this. Why we are getting error? So we need to rectify that error. Browser will hang and we won't be able to test it properly. So let's go back here in this home page, and we will see where exactly that issue is coming. So okay, we can see here we have that functionality to connect with the WebSocket, and it will try to connect with the WebSocket, and if it is not able to connect, so retry count should be maximum 10, and if it is greater than 10, that means this retry should not happen. And of course in this case I am seeing it is going in an endless loop. So let's forget this retry for now, or we can say okay, let it be there. So I will say okay, the retry count is greater than, I can say here, and you can say the system is getting hanged slowly. So I will say if retry count is greater than 10, so in that case we are not going to call this function, or else we can, how can we do this actually? So we need to have certain functionality so that it will retry until 3 and then maximum 3 or 10, whichever value you are providing here, and then after that it won't get executed. So let's see this. I will say okay, on close we will check for retry count if it is greater than 10. All right, not greater than 10. If it is less than 10, we can say okay, you can execute this functionality once more, and every time if you will execute, you just increment the value of retry count. All right, and once you are done with, you are exhausted with this retry, right? Once you are done with this, so in that case retry count reaches maximum, that means it is greater than 10 now. In that case it will come here in else block, right? And this else block will do what? It will do nothing, right? It will just return from here. So we are good now. And then what else we need to do? So we need to call this same function over here in on error as well, so that it would get rectified. And let's save this, and since else part we are not calling anything over here, so let it be there. Let me just save this and check the if Docker is running fine. Okay, pizza shop is actually, RabbitMQ is actually working fine. And how can we test this? So we should be able to see this. Okay, time to start, and we should be able to connect through this RabbitMQ on this specific link. And where can we execute this link? You can see here, right? If you will click on this icon, let me just make it big. You can see here, if I'll just click on this icon, it should redirect to browser, but it is not happening. So what you can do is you can go manually on the browser, and you can go to localhost, and you can see here 15672. If you will try to run that port, if RabbitMQ is running fine, you will be able to see this page, and it will ask you to log in. By default, username and password is of course guest. You can use the same username and password and try login in RabbitMQ. Now this is the interface which is provided by RabbitMQ, and you can see here a couple of things. Overview, we have overview tab, and there we can see all those things, ports, contacts and everything, right? And we have connection as well. So if we are going to make any connection with the RabbitMQ, that connection will come over here. Similarly, if we are going to use channel, create channel, as many as channel, those all channel will come here on this tab. And then we have exchanges over there as well. So this exchanges will not do nothing, but it will route the specific message to a specific queue. And then we have queue and stream as well. So all those queue will get listed over here, and we will see that in action. Let's run our backend server, and we should be able to see that. And before that, let's see if this our client application is working fine. And how can we see that? For that, I'm going to say okay, let's close this. Lot of things is opened on my system, that's why it's getting slow. So I will just close all those from here, so that it should be working very fast. And yeah, we are good. So I will say view, not view, localhost. We'll go to localhost and see if that works fine. So now we can see okay, the page is loading, but let's see if error is there. So there's no error so far, 4 errors are there. And go back to console, you can say 5, it should be maximum 10, not beyond that. So let's see, 1, 2, okay, 8 is there now, 9 and 10. Now there should not be more error. Okay, still it's increasing. Okay, finally 11 error, it stops, right? Because we put condition as a 10. It will start from 0 because the counter is, retry count is starting from 0. Let me just refresh, clear this console, and what I will do here is I will run my server now in this time, and we will see if that works. For that we need to go inside server folder. Alright, we are inside server folder now, and then we will simply say how can we run our Golang application. We know that we need to use a certain command to run our Golang application, but then this time I'm going to use air. Air is nothing but a package in Golang which will actively watch for changes in any of the file. So any file changes, it will rerun that application. So for that I am going to init the air, so I will say air init. Alright, so it will just create a configuration file over here with TOML configuration, and you can see here, and now we should be able to run our application with air. And before that I am going to clear this console, okay, and just type air over there in the command and your application should be starting properly. So let's see what we are getting over here, and if everything works fine. So it's actually building. Initially it may take time in the first build, but in the subsequent build it will be very blazing fast. So meanwhile we'll just wait for some time and we will see how it works. That's actually taking a lot of time, so I have closed the server from there in the VS Code, and that can be issue with the VS Code as well because that is running too slow in my case. And I will just open this command prompt in the same folder and I will try to run it from here and we'll see if that works fine. So I'll just enter this command in here, air, and then it should be working in the expected way. So let's see if that works here. I will just maximize this command so that you can see all those logs over here. So let's wait for a couple of seconds and we should be seeing our server up and running. Now we can see here our application is running perfectly fine, but there's one issue over there. And what is that issue actually? We are seeing that it started consuming the message but then failed to consume events. Why? Because we don't have that kitchen queue over there. And I said this earlier, you need to have that queue present in the RabbitMQ so that it will start consuming message or it will start publishing the message. But if you don't have queue, you need to create that queue either through code or from UI, RabbitMQ UI. So what I'm going to do here is I will just go on UI and I will go back here. You can see here we have option of queues and streams. So here I will say add new queue and then I will say name of the queue, and this time I'm going to say kitchen because the name of our queue is kitchen. And what else we need to provide here? Okay, this is durable since we defined the queue there as a durable, right? Even if this system RabbitMQ crashes, when it restarts, message should be there, right? So we have all those things over there, and this all things we don't need because that is not related to our functionality. If we need more control over the queue, we should be configuring this all, okay? So what I will do here is I will just add a queue and then you will be able to see this kitchen over there, and then our application should be basically working fine. I will go back in our application and I will do restart and see if that works. So let's just save this once more and it will trigger restart, and we should be able to see what exactly happened there. So we can see here now our application has started on this port, and then we have two routes over there, and apart from that we have consuming message started over there which is getting logged here. Now what I will do here is I will just go on UI since we are going to check this functionality from our client. I will say okay, just add, okay, I created in such a way that whenever you select such item it will come in a green color, okay. so that you can recognize, okay, this specific item is selected actually. So I will say, okay, I'm going to put my name this time, very first order. I'm going to place, okay, I will say order, and you are seeing something is breaking over there. But before that, you can see here order slash create not found. That means this route, it is unable to find this route. Why is that so? Even though we have registered those routes, and whatever WebSocket connection, it should be able to connect with the WebSocket at least. So we are seeing that we are triggering this request, but from the WebSocket as well we are not getting any messages, right? So there can be issue with our application. So for that, let's debug that where exactly the issue is. So very first I will go back in the route file, and here I will search for order route first, because that is responsible for creating the order. So we can see, okay, this should not be get, actually this should be post. So we need to change it to post, and let's save this. Our server should actually restart, and we should able to get those messages, not messages, but we should be able to get those requests on our server. So we have changed that, and then we should have a WebSocket route as a get, of course that is get. And then here if we'll go on the routes, we can see WS is there for WebSocket as a base path, and for orders slash orders is there as the base path, right? So we are good with this, and with this configuration it should be working fine. And for that, what I will do here is I will just refresh this page and see if that works fine. So we can see here our connection is actually connected successfully, and we should be able to see here that as well. You can see here start taking order. That means the message which we are passing from our application to the client, right? Like this pizza shop is open and we are started taking order. So what I will do here is I will just put my name and try to order something. All right, and expectation is basically it will call API, it will call one post API, and then the data should be visible over here, the order number should be visible over here. So let's see that. Let me trigger an order. You can see here status ordered, and once that order is successful, once we will get the message back from the WebSocket connection, that order has to be, you know, changed to something green color or some yellow color. And for that we will just check what it is actually there, but you can't see the color. So let's debug that as well, and we will make it perfect. So for that, what I'm going to see here is just go in WS connection, and since we have the functionality to change this order status from the WebSocket, so we should have that message here in the WebSocket. So we have that message actually here, and this time you can see here the message is order prepared successfully. That means as soon as we posted this order, already chef is waiting there and it prepared this order very early, right? But this order message is, you can see here, not order but order status you can see. So if I'll click on this message, I should be able to see this message here, and here the status is delivered. All right, so in case of delivered, we are not checking anything over there, so we are not basically applying any CSS class, so that our that order tiles should show in a specific color. So for that, what we can do here is we'll just go back here in the home page, since this home page is responsible for all those order page and UI. So I will say, okay, in case of delivered, I should have one status here defined. You can see here tile, right? So I will just define one more over here. I will say in case of tile prepared, or in case of, let's say, tile dot ordered, not ordered, let's say delivered. So in case of delivered as well, it should show green actually. So let's see if that works fine. I will just save this and go back to UI. You can see this is actually showing in green color because this order has been actually delivered, right? So let me add a couple of more order and we will see if that is working fine. And what I'll do is I'll just add a couple of order here. I will put some name and order it. You can see here it is coming. Now I will add more order. Okay, that is quickly getting delivered because that is working fine. I will say order, and you can see we are able to create as much as order. All right, and the order which is getting you know which is getting processed at very basically, if the order is prepared, it is coming to the first. All right, that's how I made this, and you can see since it is taking very less time, so that we are not able to see the delay. But if you want to see the delay, you can just do one thing. You can modify the client code and trigger, let's say, 100 of requests at once. That means 100 of order at once, and those all order will get visible over there, and it will show it. Basically, we should be able to see in a way that okay, this order is this specific order is getting prepared or delivered. All right. So what we can do next is, okay, we are getting order delivered, we are getting other status as well. Are we getting? So let's see that. Fine, it's happening very quickly actually. So apart from that, we need to go back in our application as well and see what are log are there. Okay, you can see here there's no message coming from the client. It is directly waiting for the client to send some message, right? But it is not coming. And of course, this time what I will do is I will just go here and I will show you how many messages are getting acknowledged by this RabbitMQ. That means how many messages getting published to this queue, this kitchen queue. So for that, what I will be doing this time is I will be coming back here in code, and I will say, okay, that's fine. We know that this application is working in the expected way, but then we want to test certain functionality, and we are expecting it to show that in a specific manner. So for that, I will go back. Okay, I'm already on this home page, and here I will say, as soon as your connection open, just fire a couple of for loop requests, and it will just order a specific item. And before that, I need to clear the local storage because I am using local storage to count all order items. And how can we do that? Not items, but to count the order number. So for that, I need to go inside application and local storage. You can see 44. So I will just clear this, and then again it will start from 1. So that is the concept actually. So what I will do here is, this time I will go here in the client code. I will, as soon as there's a network WebSocket connection opens, right, I will trigger, let's say 300 order at once. All right, and it should basically able to order all those. I should basically able to not. Okay, we cannot do this because we need to trigger the API for that. And how we can trigger the API? Okay, we are triggering basically API only. So okay, that's fine. So let's trigger 300 API. That means 300 or different user, 300 different customer placed the order online, let's say, right? So that all orders should be accepted by our server and processed accordingly. So let me just save this and go back to UI and see if that works. I will go back to UI and refresh this page. You can see here all those items are getting placed, but it is getting delivered as early as possible, right? You can see all those status. You can see here now it is blue, and those all are getting green as soon as possible because all of those are getting handled quickly. That's why you are seeing all those happening, all those converting into green, right? So this was the expectation. Actually, this was our expectation. It should work in this way, right? So you can see here this order is processed here, and then a lot of more order is there. So that all has to be processed and that all has to be completed, right? And if you want to see the log as well, you will come here and see the log. There's no message at all. That means all order has been placed successfully. So let me do it once more and we will see what is happening over there. So this time I'll just clear this order, I'll say delete. Okay, it keeps increasing actually, so I'll say delete. Fine, and I'm just saving that order in the client local storage as well, because to load that data default, so I need to just comment that code. I don't need that code for now, so that it will work efficiently. Okay, so for that I will just comment this code from here, and we don't need this actually for now. All right, and then I will comment the code here as well, so we don't need this code as well here, so I will just comment this code and I will save it and go back to UI. Now you can see that all order is getting placed, and parallelly it is getting processed and getting green. That means the order is getting delivered and prepared as well, right? Since we are triggering 300 APIs and those all are happening parallelly, that's the beauty of using RabbitMQ. It won't block your application, it will be able to handle lot of parallel requests and your system won't lag. Your system would be able to, it would be able to handle many requests, as many as requests it can handle, but for sure it will handle lot of requests. And if you want to scale it, of course you should be able to scale it, because we are not saving any state on our application, we are not saving any data on our application, so it will scale independently, because all those will depend on RabbitMQ message events. All right, so that is it for this video, guys. We can see this is how it is working, and then all those message, if it is getting properly processed, then this all will get started, will convert into green as well. So that's it for this video, guys. I hope you are able to understand it properly, how this queue system works when you are going to eat in certain restaurant, or you can say KFC or somewhere else. So basically you are waiting in a queue, you are ordering something, and those order is getting listed on a screen. That's what I made here. So that order is getting listed here, and then once it is completed, then that is coming on the top, right, on the very first. So based on that you are going to pick the order and eat your delicious food. So that's the concept of using this RabbitMQ, and that is it, guys. I will meet you in the next videos, and if you like this session, please put a like in this video, and do share and subscribe as well.